Good morning. Good morning, Craig. How are you today?
I'm terrific, Michael. Thanks. I hope you are as well.
Thank you. If you'll allow me, Craig, I'm going to make a couple of comments about the last couple of days, and then I'm going to introduce you, and then I know that you're going to introduce our keynote, John Bell. So, with your permission, I just want to give a brief update or a recap of the last 2 days. First of all, this week we will have we've got 640 attendees as of 5:30 Pacific time this morning from 37 countries. And I must say that that's one of the things that I'm really proudest of. We work very hard to work with people all around the world, and the fact that so many people are joining us, of course, being virtual allows that to happen. But this is a really wonderful opportunity for so many people from so many countries to come together. So great speakers, great content, great exhibitors, and of course, TMA team has put this together. We have 300 moderators, speakers, and panelists. So our team, the TMA team's done an amazing job. There's 70 keynotes, panels, and roundtables. We're bringing you Aqua Optimism during all of Blue Tech Week. As you know, Aqua Optimism, Blue Tech, and SDGs is the theme this year. Over the last 2 days, we brought together experts, and we've heard common themes about bringing together ocean and water, about the desire to collaborate, and the support of science-based approaches to understanding and solving challenges. We started on Monday with our annual cluster day, our 6th annual cluster. We had, during the morning, clusters from Europe and the United States primarily, also in a new cluster from Spain. And in the afternoon, we had Asian clusters, Japan, South Korea, Taiwan, and then a group from the state of Victoria that's thinking of creating a cluster there as well. On day 2, we started with Dr. James Green, the chief scientist of NASA, talking about the intersection of the space economy and the blue economy, which I think we all realize is incredibly important. And he talked about, as we talk about, how academia, industry, and government need to come together, and talked about how they would like to do more with blue tech companies. A lot of emphasis on the importance of research and ocean observation and how blue tech companies can assist NASA as they look at the ocean. Equally important is working with industry to find viable solutions for market needs, and they recognized that, as did all the speakers on Tuesday. Tuesday was co-hosted again this year with Scripps Institution Oceanography, the Applied Ocean Science, Advancing Marine Biology Observations for a Sustainable Blue Economy, and it was a great day. At the end, Dr. Margaret Leinen and Craig McLean did a great wrap-up for all the amazing speakers in the course of the day. So on the one side, we had Applied Ocean Science, and at the same time, we had the Workforce of Tomorrow that started with Jim Delgado, Senior Vice President at Search, and the former underwater archaeologist for NOAA, who brought really the storytelling of Star Trek and other science fiction events into the world of the ocean. Great storyteller, and he talked about the sense of the importance of storytelling and audacious thinking in the ocean exploration. And of course, NOAA and NASA working together. And so I think we've had 2 incredible days, clusters day 1, and on day 2, applied ocean sciences and how do we intersect the blue economy and space economy, and then the workforce of tomorrow, education, including the introduction of our new Blue Tech Aqua Optimism curriculum that the TMA team had worked with an outside group that's a TK through 12 curriculum, and we hope that you will go back and listen to all of those. The ones that are of interest to you, all have been recorded and will be available on our TMA Blue Tech YouTube site. We want to thank our sponsors, our exhibitors, and all of you as attendees. This would not be possible without all of you. As we began this journey, gosh, really 7 months ago, when we made a decision to go virtual, which certainly with the value of time was the right thing to do. The TMA team, since we'd never done this before, and we're a small team as it is, got together and has done, I would say, the team has done an incredible job. So to you, the sponsors, to you, the exhibitors, to you, the attendees, to all the speakers, a great thank you that make our event great every year. I want to do a special thank you to the IUS program, Integrated Ocean Observing System, as a sponsor, Ocean Pact, and the Port of San Diego all stepped up to larger sponsorships, but to all of our sponsors, thank you very much. So what I'd like to do, Fale, if you could bring back Craig, I think what he and I would like to do is just chat a little bit before we bring on the talk from John Bell. So I don't think that many people need to be introduced to Craig McLean, but I will do it anyway. Craig was a ship operator for a long time in the NOAA fleet. He's an attorney by background. He's a great friend and somebody who's been an amazing supporter of blue tech and blue economy. And for those who are with us on Monday, Craig has been the master of ceremony for 5 of the last 6 Blue Tech Cluster convenings, which are by invitation events. But his day job is as the assistant administrator for research from NOAA. And from that perch, he looks all around the world. He works with the Europeans and with really organizations around the world. And so, Craig, maybe you and I could just talk a little bit about what's going on in Europe and any comments you'd like to make over the last 2 days, and then let's talk about what we think what I know we're going to see, because I saw it early, from John Bell.
Well, thank you, Michael, and I appreciate the opportunity and the kind, welcoming introduction. It seems to me that if we look globally right now, there are some remarkably progressive policies that are coming from Europe. And the ability to integrate those policies with where we in the United States have been is very much front and center on our agenda, and it has been, as we've worked on a number of things that you'll probably hear more of through John's opening commentary and his plenary remarks. But in looking at the progressive nature of what Europe is doing, they seem to, as an aligned government, have gotten ahead of some of the problems that we're facing. And we talked earlier about the Project Starfish, the 5 points that the European Union is advancing. I'm sure you'll hear more of that from John, but they basically embrace global problems and align and design strategies for them. Now, I did want to mention, and I just dug this off of my bookshelf here, back in 2004, many of you may be familiar with this document, but it's the Ocean Blueprint. It was the U.S. Ocean Policy. I'm trying to align my camera here, I'm sorry. But this document was in 2004, and it's the last time that we as a nation really undertook a comprehensive ocean policy look. And I think if you thumb through that, there are a lot of elements that are still very valid, but there have been new and emerging elements that we need to be contemplating and looking at the strategies we would use in order to address and push back the negative forces that are overtaking us. Pollution in the sea, climate change, how we adapt, how we mitigate, and how we substantially address coastal resilience, where many of the economic earnings of private citizens have been invested in our country, in the United States, and in many others. So there are a lot of problems that we're confronted with, and I think it's a healthy organization and a healthy collection of governments that look at what each other is proffering as the set of solutions. And Michael, as I look with celebration to our ability to have worked with you and helped to support TMA Blue Tech and the Alliance, is to realize that there are certain things that governments can do that private sector is not quite ready to do. Certain scientific investments, certain monitoring systems that really there is no business model yet to conduct. And that's the role of government. Much as we see in space, the first space shots were government directed. And now we have just launched through SpaceX, a private commercial firm, the transportation of our astronauts to the space station. I think, excuse me, many of you might have seen that live on television, which is quite exciting. A new era in space travel and in space economy. So if we don't get industry involved in the blue economy, we will not have a blue economy. Now, do we have one already? Most certainly. The United States measures that at about $370 plus billion a year as a contribution to the national GDP. And I think, as you know, the blue economy in the United States is growing faster than is the overall GDP. So this is an area ripe for investment. Things are happening now around the globe, as we'll hear from John Bell, what's happening in the European view. There's an Asian view. There's a North American view. These are very harmonious. There's an African view. Every community, every continent is very much involved in this. And we're realizing that these are global challenges. These are not just unique domestic challenges. Now, for some of the small island, large ocean area nations who are watching sea level rise and threaten their population and their stability, that is remarkably concerning. And that's a reality that many folks are enduring. But from the larger scope of the Earth's sphere, what's happening with climate change, what's happening with sea level rise, what's happening with pollution of the sea, fisheries harvests, I think the United States can be proud of our recovery from overfishing, but there's still a lot of overfishing around the globe. There are many things that we could be doing. And by talking across borders, we find business opportunities to see where solutions for these challenges can be found. We won't regulate ourselves out of all of these problems. We have to be inspiring through informing the business community as to what an opportunity there is to have a circular economy, not a linear economy, and to be engaging business in the opportunities to sustainably utilize and further develop the resources of the ocean while constantly protecting the ability of the ocean to, number one, recover from our past insults, but number two, guarantee that the future will be able to harvest the same kind of gain and prosperity from the ocean space as we see. Now, Michael and TMA Blue Tech is always ready to remind me of the importance of water. And there is a water component of our agency in NOAA. Bigger picture is, where are the water sources going to come from in the future as populations grow? Where's the technology to recycle water, to harvest fresh water from salt or other means? And I think that's an important opportunity for us to not overlook and to make sure that we're prepared to include this in the discussion, as you'll find our European colleagues have already done. One of the challenges that we face in the United States is that we have more than a dozen, in fact, 17 federal agencies who have an ocean portfolio. We have a similar number of federal agencies that have a water portfolio, water availability, water forecasting, agricultural related aspects, etc. And what we've not really done is build that bridge between the two in a meaningful and strategic way. And I think that's something that the industry side, that Michael, your leadership, TMA Blue Tech, and your inspiration has really given us, that I think opens our eyes towards a further opportunity of coordination and collaboration, but also invitation to the commercial sector to get on board. I will say this once again, we don't have a blue economy if we don't have industry involved in helping to co-design, develop, or even design and lead some of the aspects of where market-driven opportunities will be to feed people, to clean the ocean, to make sure that our products do not have harmful byproducts, but that there's a byproduct stream that has its own economic use and gain, basically a circular economy. And I'll just conclude, and then back to you, Michael, in case you want to dive deeper in any of these subjects, or if it's time for us to go on and introduce John. But you have been the articulator and the aggregator of these interests, and I have to say, personally and professionally, I do not see that the blue economy would have the notice and the progress that it has if you hadn't started what you're doing here and bringing TMA Blue Tech and all of the many people. The numbers that you cited are staggering and very impressive. 640 participants, 37 countries. The rest of your statistics are just amazing. So I congratulate you on another successful year of growth of the enterprise intellectually, organizationally, and in the reach that we have in order to acquaint people with the importance of the blue economy, blue technology, and really how we're going to be able to address and solve the world's challenges, the global challenges, with economic prosperity and preservation, protection, and sustainability of the oceans. So back over to you, Michael.
Well, thank you for that, Craig. That's a wonderful introduction to, I think, what we're going to be hearing in a minute. Again, for those that have not looked at it, look up Mission Starfish. The EU has 5 what they call moonshot missions. One is to solve cancer, for example, but one is focused on essentially creating an ocean and water policy for the EU from 2022 to 2030, and also to create a EU-wide ocean and water agency. And so we're going to hear in just a moment from John Bell, and I hope afterwards we will go directly into the first panel. And so enjoy your day. Please go to the agenda in Whova and find the sessions both today, tomorrow. We look forward to working with you. Craig, I'll let you have the last word, just introducing who we're going to see now, John Bell, because he's a great speaker. I just wish he had a beer that he was nursing right now as he was talking. So last word for you, then we'll start with John.
Very good, Michael. Thank you. Well, I appreciate your providing me the opportunity to introduce John Bell. John serves today in the European Commission in a very high role that's very much involved in the very strategies that we're talking about and that you'll hear more about. But just a brief word, in the European Commission, many Americans may not be as familiar with the system of governance. Within the European Commission, comprised of all the members of the European Union, are Directorates General, or abbreviated as DGs. The Directorates General have various portfolios, and one of the very important ones that's relevant for us is the Directorate General for Research and Innovation, or DG Research and Innovation. Within that, John holds the position of the Director for a Healthy Planet. And if you consider that as a job title, that's remarkably exciting, stimulating, and imaginative. So it's therefore fitting to have somebody who is remarkably exciting, stimulating, and imaginative, and that is John Bell. His portfolio includes climate, bioeconomy, food security, biodiversity, circular economy, Earth observations, oceans, water, Arctic, and bio-based public-private partnerships. Putting all that together, it's easy to conclude that that is an appropriately named portfolio of Healthy Planet. And it's that type of unifying outlook that John brings in his strategic generation of these thoughts and the ability to market these thoughts and gain partnership with other players. Speaking of partnership, I came to know John because the Galway Statement, which was between the United States, Canada, and the European Union, signed in the beautiful city of Galway, historic city of Galway in Ireland, was at the genesis of John and several other folks who decided that it was important for us to focus on the North Atlantic scientifically, in a cooperative way, and the Arctic. So we signed that agreement, and we've been working at it quite well together. John is the lead for the European Union. I am the lead for the United States, and Dr. Aaron McPherson from Canada is the rep for our Canadian counterpart. So the three of us have been working at this. I do want to give a shout out to Trevor Swordfogger, who was the original Canadian representative, and Trevor has moved into a different portfolio, and we admire the work and contributions he had made as well. But John has generated with the Galway Statement this cooperative enterprise, which is titled the Atlantic Ocean Research Alliance, US, Canada, and the EU. And that's even broadened with John's vision and wisdom of extending it to the South Atlantic, not just the North Atlantic. That brought about something that's called the Belém Statement, because it was signed in the city of Belém. And it extends the agreement to include Brazil, South Africa, and now other nations are joining. But that wasn't good enough. John realized the potential of this and expanded it now to an all-Atlantic research alliance, so that the nations of the South Atlantic borders, the North Atlantic borders, are now working collaboratively in this manner. So I asked you to strap on, because he'll take you on a journey. He's an excellent speaker, as you know, and he's also a dear personal friend, as I've come to know over the years. And I introduce to you the Director of Healthy Planet, John Bell.
Hello, I'm John Bell. I'm the Director of the Healthy Planet Research and Innovation Director to the European Commission. And to our dear colleagues, Michael, Craig, ladies and gentlemen, I'd like to thank you for your invitation to Blue Tech Week 2020. I can't be with you today, but I'd like to take this opportunity of reaching across the ocean that unites us to emphasize the importance of restoring our oceans, seas and waterways and deepening the already established relationships that we have between policymakers, researchers, innovators, investors and citizens. It is a good moment to look and see that in the affairs of humankind, there's an ebb and flow as there is in the oceans, and we're very much buoyed recently by the great news coming from your great country that you have a new president-elect and a new vice president ready and waiting to take forward the challenges there, and we wish you a very progressive, peaceful and prosperous time in the period ahead, and you can count on continued cooperation, close cooperation from the European Commission, the European Union, your friends and colleagues on this side of the pond. And also we see with the emergence of science-based solutions to the great pandemic that is uniting everybody on this planet, showing us the way ahead, that science and cooperation on science and global cooperation on science will always find a way through even the most difficult problems that we face as human beings. So we're talking about oceans and waters, our planet's life support system, which are clearly under threat. We are saying here in the European Union, where there's been a significant new direction set in the last year or so towards this European Green Deal, where the European Union will commit all of its resources, its legislature, its diplomacy, its programs, its science, its civic effort to develop a climate neutral continent working within planetary boundaries through a fair and just transition by 2050. And we do that because we see the great challenge of the century is the reconciliation of the biosphere on the one hand and the human economy on the other. And the oceans, of course, are the connecting tissue between the two. Without healthy oceans and waters, there will be no life on Earth or the conditions for life on Earth. The oceans and waters, in effect, they are our natural capital, which are essential for well-being and prosperity, and which are critical, in fact, to the way in which value and a valuable lifestyle will be facilitated in the years to come. We're starting increasingly to understand the needs of our oceans, seas and waterways, how central they are and how much under pressure they are. The closer we look, the more we understand their dilemmas. So we're at a critical moment in human history in that we need to understand more about our oceans, our main life support system, and what our oceans need from us and what we can bring to them. 85% of wetland areas have already been lost. 66% of the ocean area is facing serious cumulative pressures, and we know that 1 million species across this planet of ours are at risk of extinction. We've reached a point of climate emergency and biodiversity collapse, with sea levels rising, floods and more extreme weather threatening our communities, and depending on where we live, there being too much or too little water, too much or too little of what is needed to maintain a high quality of life on Earth. So if we don't act now, the costs of inaction that are already being felt will dramatically exceed the costs of action. And in this reconciliation of the biosphere and the economy, innovation will be critical, because this defining task of the 21st century, we can learn from this pandemic crisis, which is the first real planetary signal that the biosphere and the human economy need to find a new arrangement, that research and innovation will be at the center of this endeavor and this transition. And if we think back, looking at the ocean aspects, innovation is de facto the algorithm of human progress. We look at the oceans, we look to St. Brendan's voyage to open up the first contact between ourselves and the North American continent. Or we see the caravels leaving Belém back in the 15th century with Vasco da Gama, brilliant innovation that transformed human history. Or more recently, we look around, we look at our friends decoding the DNA of the seas and rediscovering new medicines of the future, new sources of protein and food or energy, materials. Or we see the autonomous underwater vehicles moving and flitting around on the ocean seafloor in the new great exploration. Innovation is the algorithm of human progress and will be called upon with research to transform what is currently a dilemma into a series of new economies, pathways, societies, and ways of living. So for the European Union, as I said at the beginning, the European Green Deal, which has been launched by President von der Leyen and our Federal Commission, is our number one priority, but it's not simply a policy cycle priority. This is what the European Union is about for the next 30 years until 2050. We are kind of technocratic in the European Union. I'm the faceless functionary that you hear about, the faceless representative. These are people who are busy planning on the basis of evidence, science, public involvement and public investment on making this climate neutral goal for Europe a reality, and on working with all of our partners around the world to take the opportunity of that transition to develop new and better ways of working, living, building value chains and working within our national systems. So we're working beyond a policy cycle, an investment cycle even, to this horizon in 2050. And we have an ambitious package of measures, a roadmap for action setting out how this long-term vision is to be achieved, bringing together the environmental, social and economic transitions that are necessary so that we don't leave not just the planet but anybody else behind. We have a new growth strategy called the Next Generation European Union, which has a new recovery and resilience facility and a just transition fund. And this is in total a 1.7 trillion euro initiative. It's the largest action since the Marshall Plan came from the States to bring people back together in Europe 2 generations ago. And it will drive things like green and digital transformations, a renovation wave in Europe, a real green and blue renaissance will be directed and driven and encouraged and funded and invested and innovated for over the next 30 years. This is the great chapter of the next great generation in human history. So research and innovation will have to move into the position away from simply being an observer at distance to being an enabler of this Green Deal transitions with all the major work streams: climate, energy, industry, circular economy, buildings, mobility, food and farming, biodiversity and ecosystems, pollution, space and so forth. We're at this critical moment of transition where science is shifting from observer to actor, from evidence to prediction, from research to policy. We need science to light the way to the 21st century by demonstrating, piloting and scaling up approaches and solutions. And we need here a new era of blue enlightenment. We need to turn the lights on for human history in the way ahead by turning the lights on in the ocean and understanding how that pathway is driven by nature's great driver. We've kickstarted this off by launching a European Green Deal call under the end of Horizon 2020 with a budget of €1 billion. It's a major cross-cutting call focusing on breakthroughs in the 8 big policy areas and the 3 cross-cutting platforms of the Green Deal call to get things moving. I strongly encourage you, if you're not already involved, to take a look at that. The deadline is January the 26th. We're looking for impact-focused approaches supporting the development of ideas with pilot applications, demonstration projects, fostering innovation, experiments and products, new and digitalized ways of approaching the future, producing tangible and scalable results in a short time frame. The call will mobilize research and innovation in support of a just transition, encouraging citizen engagement and empowering individuals and communities to actively participate in these transitions. As I said, the call closes on the 26th of January. We're launching our new public-funded research and innovation program, Horizon Europe Framework Program for Research and Innovation. It's been formally adopted this year. The first calls will be launched next year, and offering new policy instruments beyond traditional research and innovation topics to drive green and blue transitions. Direction is something you will see in all of the work of public policy and instruments over the coming years. At least 35% of the Horizon Europe budget will end up around, will be around the 90 billion euro mark, more or less $100 billion, will be devoted to climate-related activities. And we're now working with representatives from our countries, our member states, on a future partnership also, a program co-fund called a Climate Neutral, Sustainable and Productive Blue Economy. So we work together with governments, the European Union, scientists, researchers and innovators to develop structured ways of moving strategic agendas forward. Next year, we'll also see the launch of the European Green Deal's 4 moonshot missions. They're called Green Deal missions, or Earthshot missions, as Johan Rustom calls them in Horizon Europe. These, like the work that was launched by your last great Irish-American president, John F. Kennedy, when he sought to go to the moon, are a mobilization through research and innovation of the public imagination and all of the resources and investment to have game-changing solutions to some of the major issues that will contribute to the transformation of the Green Deal. And they're focused in 4 main areas: a climate resilient Europe, which is about dealing with the adaptation changes that are inescapable at this point in the major community risks like forest fires, floods, sea level rise, public health outbreaks, infrastructure, ecosystem rebuilding. 100 climate neutral cities will be in place by 2030. Caring for soil is caring for life. This is the restoration of 75% of soil across the European Union by 2030. That can have a significant effect on the water cycle. And of course, Mission Starfish 2030, restoring our oceans and waters. This mission led by Pascal Lamy and a very distinguished group of oceanographers, scientists and innovators. I'd like here to signal in particular our thanks to the work of Siggy Gruber and Peter Heffernan and the team in bringing this forward. Is a critical example of how we can actually make a big move forward together in finding solutions and a more sustainable solution. So if we look at Mission Starfish, this is about providing a holistic approach to the pressure on our ocean and waters by 2030. And what we're talking about here is the entire hydrosphere, from the oceans to the rivers to the sea basins, and trying to address them at scale in dealing with some of the great challenges on decarbonisation, the restoration of ecosystems, the knowledge systems that are required through completing the kind of observation systems that are necessary, and working across the ecosystems and knowledge gaps that are there to take things forward on natural resources. And the blue economy, of course, is what is built, or what will be built out of this, the blue bioeconomy which is emerging, the bioeconomy being the economic reconciliation of the biosphere with the economy. The whole economy, in fact, will be a bioeconomy in 2 generations' time. The blue bioeconomy will be central to this initiative. The missions will be addressing these critical transitions, and they will be unfolded over the coming months as very large-scale actions which will have a dramatic effect on the innovation ecosystems and ecospheres. So on that, again, the missions themselves, the documents have been released, the first draft documents during our research and innovation days here in Brussels recently, and they're very well worth a read. The mission will also act as a tool for deliberative decision-making, piloting and demonstration. One of the things we're going to be facing in these transitions is how do we involve people in long-term, large-scale, systemic and complex science-based decisions that require changes in direction, investment, technologies, where we live, how we work, where our food systems, how are they organized and so forth. And this will be one of the areas where we'll be seeking to mobilize social innovation, social science, and other forms of democratic research innovation. And we have, of course, we're in the presence of one of the great champions of science across the Atlantic, Craig McLean, a great friend and collaborator, and somebody who has been a guardian of the flame of scientific evidence-based approaches to policy. And he, of course, has been one of the founding members of the All-Atlantic Ocean Research Alliance with our colleagues in Canada and here in the European Union. In the light of the unprecedented challenges we're facing, we need research and innovation to give confidence to policy and policymakers, respite to nature, space to innovation, and hope to citizens that we can make and will make and know how to make our planet a better place to live, that the future is better. And isn't this the promise that you talk about in the States and that we talk about in terms of the European dream. That not alone is better always possible, as Premier Trudeau says, but better is an innate part of human progress. And again, that is why innovation is the algorithm of human progress. So through our cooperation in the Galway and Belém statements, we built up a multilateral all-Atlantic Ocean Research Alliance capable of addressing these common challenges. This is working from pole to pole with the North American continent, European Union, the Arctic and Antarctic, Brazil, South Africa, Argentina, Cape Verde, and other countries coming to join in our work like Morocco and so forth. This is an opportunity to build a community of research and innovation, bringing together the whole of the Atlantic Ocean in solving our solutions and bringing sustainability and prosperity and docking, bringing the knowledge out of the water and into the economy where it needs to be. We're working on the development and the advancement of science and the understanding of our Atlantic Ocean, its dynamic systems, including its microbiome, and we are implementing an all-Atlantic ocean observation system. The great work done by Martin Visbeck and his colleagues in answer to the question that Craig and I and our Canadian colleagues posed, what is a fit-for-purpose ocean observation system in terms of the needs of the whole of society and not simply of those who have an interest in the science of the ocean. Our cooperation will work to protect health and well-being of our citizens and environmental aspects and risks such as sea level rise, extreme weather, through organising and supporting knowledge and capacity sharing, open access to ocean data and information to our citizens. Our partners across the Atlantic have funded countless research and innovation projects to better understand the changing ocean and to build a sustainable ocean future. And this is why I'm delighted today to have an opportunity to talk with you, our community of partners, ranging from those involved in investment and risk-taking investor capital, and Michael, your leadership has always been very much appreciated, to our partners in the different agencies in investment in and across government at federal and state level in the United States. So under Horizon 2020, for example, if you look at the Atlas and iAtlantic projects, we've worked to assess the Atlantic's distant deep sea ecosystems and importantly, the marine genetic resources with a view to creating integrated and adaptive planning products, which we critically need for sustainable ocean economic development. The tropical and South Atlantic region have also been a major focus, for example, with concerning the development of climate-based marine ecosystem models and predictions for sustainable management, such as in the Horizon 2020 Tri-Atlas project, which also had a strong capacity development aspect. Which leads me to say that I'm happy to read that the Atlantic Autonomous Robotics Consortium, the ARC, that aims to create and manage a unique set of long-distance testing facilities for use by companies, agencies, and NGOs around the world, allowing access for testing for students, is a great piece of news. So congratulations to those of you who managed to move this key piece forward. I'd like to highlight in particular our cooperation is also building an all-Atlantic Ocean Youth Forum to equip the next generation to become ocean leaders and advocates. The Youth Forum has become the Alliance's most important vehicle to promote young people's competencies and skills by promoting all-Atlantic cooperation in early career training, capacity development initiatives, promoting fellowships mobility, and career development opportunities. The first cohort of our ambassadors starting in 2019 had begun to deliver inspiring results focused on sharing, connecting, and acting, and we're very proud to have seen them present their work at the Paris Peace Forum last week. So please support and engage in that process. Fantastic program, and it's taking the oceans home into our economies, societies, and research and scientific and innovation systems around our Atlantic. So we need a massive scale-up of social governance, business, and technological innovation to enable the Green Deal transformation to set us on a path to a clearer, greener, fairer society. We've learned from the pandemic in our learning that, the urgent need for fundamental transformation is calling on research and innovation to step up and set direction and solutions, to take risks, to deploy, to demonstrate, to scale up solutions in its timeframes that we haven't been traditionally familiar with. We need to show the public that the transitions are beneficial. We need to involve them, look to their health and well-being, look at that of the future economy, for the planet, and ultimately for those who will follow us in walking these shores together. Research and innovation as a policy for opportunity and the long term is ideally placed to play a major role of our ambition to be at the forefront of the transformation. There will be no transformation if research and innovation does not step up to set how this transformation will happen. We are all responsible individually and collectively for this great transformation that is ahead of us. It's probably the first time in human history where we could see what progress looks like in terms of the destination, the common destination that we're trying to build. And that is the gift that science and research and cooperation gives this generation of fellow citizens on this great blue planet of ours. So I'd like to congratulate you all, Michael, Craig, and all of you involved in Blue Tech Week, and wish you every success in what promises to be one of the greatest adventures in human history. Thank you.
Hi everyone, good morning to you and to my colleagues in the UK, good evening. It's great to be part of this event. It's my privilege to be moderating this event. My name's David Burton. Now, it seems to me this event is like jumping on and off a carousel, so I'm pleased to say that we're all on the carousel at the right time. Time is really short, however. I've noticed that all the bios are available online, so I don't propose to spend a long time introducing people. I'd ask the speakers just to say who they are by way of commencing their presentation, and please try to keep to that 4-minute timeline, so we've got some time for questions at the end. So I think on that note, we'll proceed. And I want to hand over in the first instance to Ping to introduce himself and then to give his presentation. Ping, over to you.
Okay, thanks, David. Hello, good morning, good afternoon, or good night, depending on where you are located at. Thank you for taking the time to attend this session. I'm Ping Tak Chai and from SeaTrac Systems, and located in Marblehead, Massachusetts, in the US. SeaTrac is a manufacturer of solar-powered uncrewed surface vehicles. Today, I'm going to talk about utilizing uncrewed surface vehicles to perform automated harmful algae bloom management in freshwater aquaculture. Next slide, please. Aquaculture products must be of consistent superior quality with consistent flavor. Most pre-harvest problems in fish are caused by algae contamination. An example is algae causes most of the off flavors in catfish, and catfish ponds are ideal habitats for algae growth. In the current aquaculture system, sensors are deployed at fixed locations in ponds to detect occurrence of harmful algae blooms. As the sensors are in fixed location, the detection of algae presence might take a while if the outbreak starts far away from the sensor, and remediation efforts are often delayed. Copper sulfate is used over the entire area to eliminate the algae blooms. Next slide, please. We are working with Mississippi State University on an automated USB-based algae management system to automate the process of data collection, analysis, issue classification, and remediation. The SeaTrac USB is equipped with relevant sensors to monitor various water quality parameters critical to aquaculture environments. Along with algae monitoring, the system will simultaneously monitor other water quality essential for aquatic life, like oxygen content of the water. For instance, if the detected oxygen level is too low, then aeration process can be started immediately in the detected locations. Next slide, please. The SeaTrac SP48 USB is a sensor-agnostic, multi-mission capable and cost-effective data collection and communication USB platform. The persistent solar-powered SP48 is easily customized based on mission requirements and has a speed of 5 knots, up to 500 watts payload power, 70 kilograms of payload capacity, and can operate from near shore to open ocean, supporting commercial, defense, and scientific applications. In the picture that you see on the slide, that is the customized Mississippi State University SP48 and has been integrated with the following sensors: the Seabird Eco Triplets, and we have 3 of them in there, a Seabird SPE63 oxygen sensor, a ProOceanus CO2 sensor, the AML, CT, and pH sensors, and also the McLean imaging flow cytobot sensor, the IFCB. In this automated system, the USB will be pre-programmed to run a set pattern continuously over the entire area, collecting water quality data. The collected data is analyzed and classified on the USB in real time to identify any water quality issues. If an issue is detected, alerts are then sent out immediately, and remedial action can be started immediately or automatically in the detected area. Next slide, please. The implementation of the automated algae management system provides the industry with real-time water quality managing data needed to enable the timely algae and water quality management, resulting in healthier fish, improved production efficiencies, reduction in operation costs, while reducing the environmental impact by decreasing the use of chemical treatments. USVs can be utilized to perform the mobile in situ monitoring solutions with greater efficiencies over current fixed monitoring solutions. When combined with the real-time data analysis and classifications, turnkey solutions or actions can be developed to react to the situation immediately or automatically. depending on what needs to be rectified. Thank you.
Brilliant. We just about got there in terms of time. Being lots to talk about there in questions, I do hope. So let's move on quickly to Phil. Phil Johnston from AutoNaut, not far from me in the UK. Phil, over to you.
Well, thank you, and what an honour it is to be here. I'm just disappointed I can't be in San Diego in person, but there you go. So I'll rattle through, but hopefully lots of questions. What I want to talk about is using our wave glider. So can we move on to the next slide, please? Grant. Using our wave glider, did I say that? No, it's not. It's a wave-propelled AutoNaut USV. So AutoNaut USV, using it to deploy a sea glider, which is a buoyancy-driven subsea craft. So two autonomous systems for the price of one. And it was a science project that emerged from the University of East Anglia, and they had a fund from the ERC. And what they wanted to do was address this problem that they have, which is access to research vessels, to get sensors in situ, often in remote and hostile areas at a given time, ideally on demand. So the idea was that AutoNaut would head out to sea. It's a little bit like a taxi service, really, and deploy the glider. But of course, the AutoNaut is at the surface, so it can collect meta-ocean data at the surface as well. So you've got two systems working in tandem. And of course, it's zero carbon, it's low cost, and it's very low safety risk. So that was the concept. And if we move to the next slide, please, I'll show you what we a quick sketch of what we did for the Eureka 4A program. It's a mission off Barbados earlier in the year, and essentially trying to better understand the trade wind alley, so the clouds, the climate circulation out there. And so it was numerous assets were involved. I think there's a few other familiar faces from the autonomy world out on display there, and it was a big success. It was great. The key element was the scientific instrumentation about Caravella, which I won't go into, and of course on the glider. So I'll skip on to the next slide, please. I'm moving quick because I have a video I want to show you. So what happened was we sent the Caravella USV out from Barbados. So we directly launched it from the shore, and it transited out to the study site. En route, it was apparent that we wanted to deploy the sea glider, and we sent a remote command, and it unhooked, and off it went. Now the mechanism is built to be robust. It's pretty simple, really, but we want to send it down to the Southern Ocean, so it's got to be tough. And it deployed very smoothly, and the sea glider did a quick communications check, and then skidded down to depth and completed its mission. Meanwhile, the AutoNaut at the surface formed an hourglass transect, collecting data at the surface. And it was a total mission of 33 days, so they had slightly different missions at this point, but the AutoNaut then returned to land, so no personnel went to sea to complete that mission. The sea glider was then picked up by the research vessel, but other than that, it was a beautiful example of an uncrewed mission. So move on to the next slide, please, if I may. I may even have time to spare. Further developments then. What this really unhooked for us was it was a great mission in itself and a great development. It's been a pleasure to work with UEA and other consortium members. Was that potential here is multiple. So deploying sea glider is one thing, but the idea emerges of, well, how about we put a cluster of smaller AUVs on there? So the EcoSubs idea, micro AUVs, so we can put a cluster on them there. The AutoNaut is at the surface. Perhaps it reacts to a trigger event, or it's got a command from shore to deploy those AUVs at will, and they can investigate an event further. We've also got the concept of, which we've trialled earlier, I think last year, of a comms hub. So AutoNaut at the surface operating as a comms hub to subsea assets such as AUVs. And of course, the next step for this particular program is to send the combined system of AutoNaut and Sea Glider to the Southern Ocean. So that's going to be a big test, but it's not an accessible place, so it will be an interesting science mission. And finally, if there's a little video that could be showed, that would be great, and I can wrap it up. That would be great.
us as well. But there's lots to pick up there in terms of questions, particularly the acoustics piece around that. So let's rapidly move over to Michael Jones from SubSeaSail. Michael, over to you.
Great. Did you bring up? There we go. So most of you know me through TMA Blue Tech. 3.5 years ago, I started a company with 2 partners, and I'm the managing partner of SubSeaSail. What you see on the right is an actual picture of our vessel that we sold to the U.S. Army Corps of Engineers. Next slide, please. Obviously, the ocean's a big, lonely place, and our goal is to develop 100% energy harvesting, innovative, long-duration platforms and sensors that are affordable enough to be used globally. So our vessels are disruptively affordable, very easy to carry. The one you see is about 28 kilos, so it's easy to deploy. Next slide, please. All the things that are bolded is what I'm going to hit on. We create unique and capable platforms. We try and say engineered for simplicity, disruptively economical. They're highly scalable, so we can make them bigger. And we have a very strong both technical and management team. We have 3 important patents for the United States and a number of international patents. Our Gen 6, our Generation 6 is a TR Level 9. We also have a provisional patent on a new reconfigurable rigid acoustic array. It's a revolutionary new acoustic array. And my partner has one on a magnetometer. In the future, we'll do multi-hull variants and large monohulls. Next slide, please. So I'm not going to go through all these nice arrows, but our wing sail is hollow, so it can flood, which is important when we go underwater. There's a wing sail control mechanism, which we have the second little green bubble. That means we have no pulleys, no motors, no lines to break. And then the servo is really the only piece that's moving continuously. We do have a thruster down below, but that's used to get us out into the open ocean where there's more wind, or if we get into phantom netting or seaweed, we can back out again. And then the lower section of you can see in the green letters, the float module. We're going to turn that into a cavity so that we can submerge 100%. We've already shown we can do that to the U.S. Navy, but that will be an option that people will be able to buy. So we are wind driven and solar powered. Next, please. Lots of applications, cargo delivery, communications gateway. We're working with the Navy on that. Lots of defense applications, lots of sensor platform applications, including IUU, combating IUU. UUV deliver, we sold that to the U.S. Navy last year. And then if we are a multi-hull, we can do a launch and landing platform. Next, please. So this is a little view into our reconfigurable rigid passive acoustic array. I think most people know what traditional arrays look like. Ours has pins, so it's easy to assemble, easy to deploy, easy to store. We believe it'll be useful for about 95% of acoustic needs. Users will be government, industry, military, etc. Valuable alone. Our vessel is ultra quiet. We have no hull to speak of, so we have no slapping against the hull. So being ultra quiet means it's a lot easier to hear things. So that will be out for sale, I think, in January. Next, please. We anticipate that we'll sell combos, so you'll have one on the surface that'll have you can't see it very well, but there's an acoustic array on there. And so the ability to be below the thermocline, we will be able to listen and take temperature measurements and lots of other things, and acoustically talk to what's at the surface, which means we can be real-time communicating back. So comms subsurface to surface, of course, to satellite. Many advantages, both the price point, where we can be, ability to hide from bad actor and bad weathers, etc. Next, please. I'm just going to mention that we, on Friday, submitted a provisional patent on a new kind of a multi-hull vessel to transport cargo, and we think will be useful for humanitarian aid, forward deployment to troops, and lots of other things. Again, our vessels are will be able to go underwater. They'll go fast. These cargo, the cargo ones. And now we're working on making sure our products work out of the box and eliminating travel. Next, and I think that's it. Thank you very much. Look forward to any questions and look forward to people reaching out to us. Thanks.
Thank you so much, Michael. A lot of really good information there. So I look forward to putting some of that under questions. Now, we had a bit of a challenge with Josh. Did he make it on? Yes, I think he did. So, Josh, let me hand over to you.
Hi, everybody. I'm Josh Mehlman. I am a robot psychologist at Marine Advanced Robotics. I'm going to talk a little bit about running a multi-domain mission in a marine environment. And I apologize, I'm way outside my comfort zone talking to people, so if I go silent, just assume I'm saying platform stability. Next slide, please. This is a kind of overview of what a multi-domain operation looks like. You'll see a little diagram of a network. We've found that oftentimes just getting the networks to play nice together is one of the most complicated things about these missions. Next slide, please. First thing we're going to have to do, of course, is transit to the operational area. Being larger, the surface vessel can carry a lot more fuel, so we usually carry the aerial vehicle out to the theater. Next, play the video, please. So this is a demonstration we did with Planck, actually, and a few others doing a marine security thing in San Diego. Next slide, please. So when we launch the aerial vehicle, and of course for landing, one of the most important things is to be as stable as possible. And we think, we know actually our WAM-Vs are very, very stable compared to monohull and even traditional multi-hull vehicles. Next slide, please. This is kind of just showing a little bit of what a WAM-V can do when it's been given some waves. And we can go ahead and cut the video a little short. Next slide. So once we actually get the aerial vehicle up, we've got the surface vessel in position, we can actually run the mission. Play the next video, please. So this is a video from a demonstration we recently did on combating illegal fishing in marine protected environments. And you'll actually notice that we cut the video just before landing because we weren't actually set up. We would have needed a larger WAM-V or a smaller aerial vessel to actually complete that landing. Next slide, please. The landing, again, is more important than the takeoff even on making sure you're stable. The surface vessel is going to have to take a constant heading with the wind and speed, and the platform is going to need to be stable. Next slide, please. These guys, again, over at Planck are really good at landing, but the more stable the platform is, the higher the sea condition you can actually make that landing in. And next slide, please. Once the bird's back on the surface vessel, we can hopefully refuel and or recharge the batteries. This is an example of a landing collar that will direct the aerial vehicle to the charging ring. Next slide, please. And the most important part of the mission, usually, is actually getting all of your assets back. So we can bring both assets back into a beach or a dock or whatever. Larger WAM-V can fold and get into tight spaces. Whole thing disassembles and fits in a shipping container and even leaves a little room left over for the aerial vehicle. Play the next video, please. And this is showing a WAM-V being towed. We can easily disassemble and ship around the world to where it wants to go. there's our lunch. And we can go ahead and cut this video a little short because we're running low on time. Thank you very much.
Well done, Josh. Spot on the time front. Brilliant. Okay, let's keep the pace going. I think we have two more speakers. Phil Mengden to begin with from Swift Engineering. Phil, over to you.
Perfect. Hello, everybody. So my name is Phil Mengden. I work at Swift Engineering along with Swift Tactical Systems. I'll explain a little bit more about that later. As you can see there's our building. We've been around for 35 years. And as you can see on the right-hand side, we pretty much dabbled in manned, unmanned, ground, air, and maritime applications. So go ahead and go to the next slide. This gives you a little bit of understanding about Swift in general, and will give you a better understanding of how our products are actually utilized. So Swift Engineering is our design and manufacturing house. They focus a lot on our CRAD and IRAD development. And we also focus on doing design, analysis, test, assembly, integration, and fabrication services for other people's products. However, when we transition our products out, Swift XI is a joint venture in Japan that we have, and we have Swift Tactical Systems, a subsidiary in the US that actually sells our products, but we are also distributors, and we will sell and operate other people's products as well, which I'll get into. We have other planned subsidiaries. We're all small businesses, and as a whole, we will remain small business entirety. Next slide, please. Pretty much this, I'm not going to spend too much time other than that we can take things from an idea and a concept all the way to commercialization, and whether that's a custom solution or something we do in-house, that is up to our customers. Next slide. So this gives you a 35-year journey of how Swift started. So we started off as a race car company. So as you know, race cars, lightweight, fast things. Applied that over to the aerospace field. And from there, we've pretty much gone every OEM. We've worked on different products. But from that, we started designing our own products. So we actually developed the Swift Killer B, which is that bottom right-hand left picture right there, sold that IP off to Northrop Grumman. And from there, that was the first launch and recovery UAV. We started developing our VTOL, which I'll get into later in 2014. We built the Echo Voyager and Orca, the 50-foot unmanned submarine for Boeing and the Navy there up the 2015. We're still working that program today. We've gotten a few NASA contracts where we've developed some robotic arms. We've done some AI software development. And from there, we've also developed a few different types of tactical UAVs on the right-hand side. So next slide. This is pretty much 15 years heritage in UAS. And they range from Group 1 to Group 5. We do trade studies, so we can take payload trade studies, we can take radio trade studies to do comms, figure out what endurances are. So we have all that capability in-house versus just providing products. Next. This is the main product slides. This is the main where I'll focus. We have the Swift Griffin. That's a 2-hour aircraft that has been, we've sold 24 of those recently. We're hitting more production out this year. Flies for about 2 hours, 1 kilogram payload, and about 15 to 20 kilometer range. We have a Nest Hex, which is basically a UAV in a box solution that we've provided to customers, whether that's on a boat or on land. We also have our Falcon Quad that's separate from the actual Nest Hex application. We've also talked to other people such as Planck and other quad providers. You'll notice here that some of these weren't on our actual product list, and that's because they aren't ours. Like I stated, we solve system-to-system solutions, so we have multiple products to attack the entire picture and the entire problem. We partner with Deep Trekker and distribute and sell some of those. We have a blimp system, so that can be used for a tethered system that doesn't need to move. It's a lot cheaper to maintain than a quad or a tethered quad because you don't have all the rotors on it constantly. The 12-hour gas-powered up at the top, so that's entered manufacturing actually last month, and our first deliveries to customers are June of next year. That's for 12 hours with about a 10 plus pound payload capacity. Next slide, please. So some examples of missions that we've been doing, we did 2.5 weeks out in Japan, and we did anything from search and rescue over to orthomosaic mapping. We did a land moving in a valley and did an entire localized map classification to see over time to see how that was actually changing. You can see bottom left is our seawall application. I'll have the next slide on that one. I'll go into more detail. So search and rescue. any type of maritime applications, whether it's on the ground, wildlife observation. We can do that actually on maritime activities. This is the big one that we did recently, though, where the seawall actually is 40% of the entire 22,000 mile coastline, and we did the entire seawall, and we're able to basically map the entire thing and show what has been shifting, what's not needs to be repaired over a long period of time. So some applications, quite a few different products. That's what Swift is, and I think I believe covers my presentation.
Oh, well done. Brilliant. A lot to talk about there during questions. So Dave Twining, last but not least, let me introduce Dave. And from, just checking, from Planck, and we've heard a little bit about that already. So Dave, over to you. Look forward to hearing.
Yeah, thanks everybody. I'm Dave Twining from Planck Aerosystems. I'll race through these slides, but I want to talk a little bit about kind of the maritime applications for aerial robotics and what Planck's kind of role in that whole ecosystem is. Next slide, please. First, I'll talk a little bit about the technology. Next slide, please. Next slide, please. There we go. So Planck really focuses on the embedded autonomy, so embedded software and sensors that go inside third-party aircraft to allow them to operate from moving vehicles and vessels on land or at sea. There's a number of features and challenges there. Some of them have been discussed previously. Precision takeoff and landing, networking is a big challenge. Mobile specific fail-safe behaviors is actually probably one of the biggest. Right, what to do when when something goes wrong. You don't want to just go and land in the ocean, and a number of other things as well. Next slide, please. So we take that embedded module and we can put it into a number of different aircraft. We feel that there's not one tool that's perfect for all missions. So you got to really find the right tool for the job. That can be small quadcopters, that can be tethered systems, large heavy lift multi-rotors, even some fixed wing vertical takeoff and landing systems, more persistent ISR type of missions. Next slide, please. So what's the point, right? You have these aircraft, they can operate from vessels at sea. But what do you do with them? So next slide, please. A few examples using small unmanned aircraft for ISR, right? Launching from small boats, going out and finding objects at sea, people, boats, beaches, just doing quick assessments. Next slide, please. Deploying UAS from USVs. For a range of applications from ISR, security, inspection, getting USVs to places that maybe you don't want to send people. You can see on the right there, that's the WAM-V and a quadcopter launching from that for a naval exercise. Next slide, please. We also use the same embedded autonomy module to do tethered UAS from vessels. That is very helpful for essentially elevating a communications node, establishing a communications network through other robots that might be in the vicinity, be it surface vehicles, be it things on land, but really getting an elevated persistent platform and not having to worry about actually. Next slide, please. We also have an active project in the UK doing automated man overboard response. We're actually really excited about this. Concept is somebody falls overboard from a large ship. That ship's going to take a while to turn around and go find the person. Anybody who's spent time at sea, especially in the search and rescue domain, understands finding people at sea is not easy and time is really important. So the concept here is you push a button, aircraft launches, goes out, automatically detects the person in the water, drops a life-saving device, and then stays on station until rescue can come. Next slide, please. So that's just kind of a quick and dirty overview of some of the applications for aerial systems in the maritime environment. There's many others, but I'll stop there and we can jump into questions for the group. Thank you very much.
Yeah, no, thank you very much, and really rich material there for discussion. Perhaps I can kick off with a question while I wait for questions to come up. It does seem to me that this issue of interoperability is a key issue for potential customers moving forward. So I don't know who'd like to take this or to kick it off, but my question is enough being done to define standards for command and control, control stations, for information exchange, so that if a customer buys one of your solutions, they don't have to buy, for every solution, they don't have to buy a complete new infrastructure. So what is being done, or what could be done in that space of interoperability to allow the market to flourish, to allow multiple solutions to be procured, but within an understood framework? Who would like to take that?
I can take a quick start, but I think I can transition over to some other people here real fast. One of the things that we're doing is, just like you said, is the reason we are trying to take a system-to-systems approach is so we can provide the customers an entire system versus them having to go out themselves and buying one system here, one system here, one system here, and then them having to do the work themselves. So our purpose is to take everyone else's systems and help the customers actually do that work up front. So then when they buy the system, it will already communicate. And people like Planck and people like WAM-V and SubSeaSail, and I actually, unfortunately, haven't talked to the other two folks here yet, but I'm sure that's down the road. But those people are people we want to integrate into our structure to help do that process. But I know WAM-V and Planck, and they've done a lot of actually interoperability testing with their products, so I'll probably transition over to them.
No, thanks for that. Anybody else would like to chip in on this important issue?
I can talk a little bit briefly on that. One of the things that we always try to do is make sure our systems are using off-the-shelf stuff. So our network is a pretty vanilla network. Our command station is a generic laptop. Even right down to our remote controls are off-the-shelf Xbox controllers or hobby systems. So everybody, not everybody, but most people already know how to use and how to integrate these systems into.
Thank you. Any other thoughts or comments?
Well, I'll make an observation. I mean, we are a manufacturer of vessels and sensors, so our goal is to make them easy to integrate. There are other TMA Blue Tech members that work on interoperability, and I think that what Phil Mengden was talking about, they're a great example of that. So I think our role is not to try and do that as well. And I assume the other guys that have great technology are focused on making their technology as easy to use as possible that can be integrated into somebody else's system of systems.
Let me throw another question into the mix then, and I'd welcome your views on the key challenges moving forward. You know, the work I'm doing, it's focused not only on the integration of surface vessels and air vessels, but subsurface also. The issue of bandwidth, the issue of data fusion, data flows. Welcome some thoughts on the big challenges out there that we need to address individually or collectively. Who would like to kick off? Dave, can I ask you to speak on it?
Yeah, sure. I'd be happy to. Yeah, I mean, you hit on a lot of the very persistent challenges, right? Bandwidth. You generally have sensors that can capture far more data than you can transmit and distribute, especially, you know, so just at sea in general. Satellite links are expensive, so pushing more and more to the edge, especially on the data processing side, I think will be increasingly important. It's not trivial, but it is important. increasing the level of autonomy of systems is part of that, right? If a system has a failed part and it's out in the middle of the ocean, or even just relatively far from shore, being able to reliably go retrieve that system, perhaps with say you have a UUV and you want to go retrieve it with a unmanned surface vessel. That's not easy, but it is important. I think a lot of the companies here are getting closer and closer to that reality where it is something more of a push button operation, but there's still a long way to go.
You touched on a really important issue, and maybe this is the final question that I'll throw in the mix and see if anybody wants to pick it up. It's on trust. You talked about the issue of maturity of autonomy, but again, in the domain that I operate, there is still this issue of trust, of reluctance to trust these vehicles and the associated sensors. Thoughts on it? Who would like to take that?
If nobody else wants to jump in, I can talk a little bit about that. Sorry, somebody else is about to start.
Yeah.
Phil, or Michael?
You mean by trust? Do you mean how our various systems work together?
I think I'm really talking here about human autonomy teaming and the barriers to exploitation.
I'll do a quick statement, which is one of those is our contract in the Caribbean, where the areas down there aren't exposed to unmanned systems as much, and so part of what we're doing is creating a center of excellence academy for them. So we're going to be training personnel and Bahamians on the actual how to operate UAVs, how to do MRO and depot activities, how to do the.
Oops.
I think somebody's come on early. I'll throw a question at this young man in a moment. Phil, any more thoughts on the issue of trust?
Leonard, you've come on a little too early.
Oh, sorry, guys. Cheers.
I can start an answer, but I'm happy for someone else to finish it. I think it's time and missions. Each case study by whoever system, by whoever company, is for the common good. It's for the good of the industry that it grows and grows. I think just to note, I think we've got to be careful not to get too bogged down in the dazzle and how clever it could be. These systems work when they work. If they don't need to be clever, they don't need to be clever. So it's about being driven by the need.
Okay, can I just say thank you? Thanks for all the speakers. Some great pictures. I'm sorry it was so rushed, and I'm sorry I had to hurry you. It'd be good I'll send an email out. Perhaps we can keep in contact, and if there are any follow-on questions, very happy to manage them. Thanks, guys.
Thank you very much.
morning, everybody.
Morning.
Morning. Yeah, my slide
Almost
up.
afternoon here in Ontario.
Yeah, I have my slide. If you could pop my slide up, I appreciate it. Thank you. Okay. Yep. Okay. Good morning, afternoon, and evening to all. My name is Bill Lingsch. I'm the U.S. Underwater Glider User Group Coordinator, and on behalf of the NOAA IUS Program Office and its Director, Carl Goldman, it's my pleasure to welcome you to our panel, our special panel on below water observation. The UN 2030 Agenda for Sustainable Development was adopted in 2015 with 17 global sustainable development goals. It's a plan of action for people, planet, and prosperity. TMA Blue Tech also embraces the idea of aqua optimism, to think positively about the future of our water systems and provide forward-thinking solutions to the current problems. The panel today will focus on Sustainable Development Goal 14 that pursues to conserve and sustainably use the oceans, seas, and marine resources for sustainable development. The world's oceans, their temperature, chemistry, currents, and life drive global systems that make the Earth habitable for human mankind. Our rainwater, drinking water, weather, climate, coastlines, much of our food, and even the oxygen in the air we breathe are all ultimately provided and regulated by the sea. It's no longer the bottomless dark pit we once thought, and preserving its resources is essential to our future. Observing and monitoring beneath the surface that was once not possible is happening now, whether it's for mitigation of climate change impacts, resource exploitation, monitoring and reducing pollutants, fisheries management, hurricane intensity forecasts, aquaculture farming, scientific research, and much more. The technology is now enabling us to turn the light switch on under the surface of the seas and oceans to observe, measure, and continuously monitor the critical events that ultimately enable informed decisions. It's our pleasure to have the representatives from the 5 companies listed here to discuss their cutting-edge solutions via algorithms, vehicles, and other engineering innovations that enable sustained observing and monitoring in this harsh environment to ultimately deliver actionable information to decision makers. In the interest of time, I will briefly introduce each panelist prior to their comments, and their full bios are available in the program app. I would first like to introduce Yael Eshel, Business Development Manager for SeaErra. Okay, then we'll start off with Rusty Jehangir, Founder and CEO of Blue Robotics. Rusty, the floor is yours.
Let's see, I think we're going to have to go to the next presentation. Those aren't my slides. All right, thank you, everybody. Let's move to the next slide here. And click ahead. Okay, so first off, my name is Rusty Jehangir. I'm the founder and CEO of Blue Robotics. We're based in Torrance, California, just outside of Los Angeles. And there's my email address if you'd like to get in touch with me after this panel. Next, please. My company has about 35 employees right now, and we were founded in 2014 with a mission to provide low-cost, high-quality components to enable the future of marine robotics. And I think that mission really speaks to the sustainable development goals in providing lots of people, lots of companies with solutions to observe underwater. In our case, we provide components, so a lot of that is about enabling researchers or other companies to build solutions for their specific observing needs. Next slide, please. I want to share a little bit about our start and how we got into this. So in 2014, we launched this product right here on the right. It's called the T200 thruster. At the time, I was just a couple years out of school, and I was doing a hobby project trying to send a solar-powered surfboard across the ocean. And I realized that there were just no affordable thrusters in the marine robotics market. The cheapest one I could find was like $700 with a student discount, and the industry standard one was about $3,000. Also, Most ROVs have 6 to 8 thrusters, so if you start at $3,000, the price is just way, way up here, right from the beginning. So decided to tackle that from a business perspective and designed a thruster that was small, efficient, very multi-purpose, well documented, and basically 10 times cheaper than anything else on the market at the time. We launched it at $100. Now it's $180, but still much less expensive than other things on the market. Click ahead, please. We actually launched it through a Kickstarter campaign, unusual for a marine robotics company, I think, and we raised $103,000 and sold our first 600 thrusters. That was our start. We've done a lot since then. Next slide, please. We launched this thruster, and then we came out with a series of components for underwater robotics, ultimately ending up with this vehicle right here, which is called the Blue ROV2. Focusing on this vehicle here because it most directly enables underwater observation, and we've sold quite a few of these around the world to all sorts of customers doing observation work. Next slide, please. One thing that makes us unique is that compared to most of the industry where you've got a typical sales process, contacting somebody, getting a quote, we've always had all of our products directly online, ready to add to a cart, and most of the time they ship in about 24 hours. You can see on here that things are back ordered. We've had a lot of demand recently. Next slide, please. And click again. So a couple highlights of this vehicle. First of all, because our thrusters were so inexpensive, we were able to put quite a few of them on there, giving us a lot of capability. We've got what's called a vector thruster configuration, which provides excellent stability and maneuverability, something that wasn't available in our price class. We've got a very affordable price point in the $3,000 to $5,000 range. A similar vehicle at the time we launched this was well more than that. You spend a lot more on an ROV than on your car. A couple of other things that set us apart are, one, that our product is sold as a kit, which helps keep the price point down, but also makes it extremely user serviceable and user modifiable. So many of our users are very technical users, but they're taking this product and they're customizing it for their needs, which allows them to observe in their environment with a very customized platform, even if we don't have the resources to help them with that. The software and electronics on this vehicle are all open source, also helping people to customize it. And last, we have 55 distributors around the world who offer assembly and customization services. So it's fairly easy to get in touch. You can make this vehicle exactly how you need it. And they're very successful doing that. Next, please. We've sold around 2,500 of these vehicles in the last 4 years or so. They're in all sorts of markets, including aquaculture, inspection, research at universities, exploration with hobbyists, law enforcement, and many, many more. My next slide shows a couple of my favorite applications, which I'll just breeze through fast before I finish up. So next slide, please. And click ahead. You can show all 6 pictures right now, so just click ahead. That first one is at Woods Hole Oceanographic Institution, some students using it for autonomous systems development. Next to that on the right is a customer in Alaska who's just a hobbyist, but was able to afford our vehicle and go collect his crashed multi-copter in a lake in Alaska. Next to that is actually a high school team collaborating with Monterey Bay Aquarium Research Institute, which retrofitted this ROV for a much greater depth and installed it for almost a year at an 850 meter depth in the Monterey Bay. Below that, the guy in the yellow jacket is NASA Jet Propulsion Lab, using the ROV outrigged with some custom sensors to measure methane leaks in the Arctic. In the middle bottom is, that's actually our Blue ROV2, but this is a really good example of somebody customizing it to their needs. This is a company working on robotic lion fishing, and they've replaced the frame with a lionfish vacuum cleaner, but the thrusters, the electronics, everything else is all from our Blue ROV2. And last at the bottom left is a company called Abyss Solutions in Australia, who's outfitted with a bunch of custom sensors, but still been able to use the vehicle, and they're doing really advanced computer vision and machine learning to do autonomous inspections underwater. Just a couple of many hundreds of awesome applications that our customers have done and have been enabled by this product. And that's it. If you go to the next slide, that should wrap it up. Thank you for listening.
Thank you very much, Rusty. We'll now hear from Sam Macdonald, President for Deep Tracker, and also a big boat advocate as well, I see. So Rusty, I'm sorry, Sam, the floor is yours.
We're interchangeable. Hello, as mentioned, my name is Sam Macdonald, and I'm going to try to center myself. I'm the president of Deep Trekker. We're a manufacturer of ROVs in Ontario, and I am not in the picture at all. There we go. The events of recent months have been unprecedented, to say the least. However, the COVID-19 outbreak has shaken the entire global order in many ways that we have not seen before, and it's thrown every strategy and policymaker out of their thinking. The intelligent, scientific, and political agencies have been caught off guard, and these events have questioned the very premise of their existence. The fallout of this event will leave us unseen massive depletion of resources and erode us with the ability to rebuild where we are. Countries can no longer pursue a nationalistic approach to emerge out of the crisis. Cooperation and synergy are the only ways forward. Stakeholders don't have the luxury to pursue their own agenda without massive pooling of resources and synergizing of efforts. The post-COVID-19 global order will need a complete reset to our conventional wisdom if we ever hope to emerge back with some semblance of normalcy. Probably it's brought us to a level of existential crisis, and realistic efforts are required to retrace our journey back to reasonable levels of growth and prosperity. But why do I speak about COVID as the opening to a discussion about below water observation? Frankly, COVID is a veritable canary in the coal mine with respect to the crises we will face in our lifetime surrounding maritime stability, ocean health, submerged infrastructure vulnerability, and climate change. Now, when I was a child in the 80s, which to my younger audience and to those who, like me, can't believe that time has gone on that quickly, is approaching 40 years, coming on half a century. All that to say, a bloody long time ago. Now, in addition to bad fashion, we had cute phrases outlining and acknowledging that a problem existed. Phrases reduce, reuse, recycle, and dilution is not a solution to pollution. But we didn't see. No internet meant that no daily photos of turtles encased in discarded fishing gear, no flashy GoPro selfie videos of surfers in a plastic wave, and even the Exxon Valdez disaster was captured by the news outlets as birds gently being cleaned by dish detergent. No photos or videos of what was happening below the waves and what deeper level of destruction was going on. But this is a bit of a digression and simplification, if perhaps an important one, because undersea resources, both living and non-living usage, present massive opportunities. However, unregulated exploration and exploitation raise major sustainable
Yeah, Yael has logged in. So yeah, Eshel, she's the business development manager for SeaErra and also the women national championship for Israel. So okay, yeah. No, I just was mentioning Yael's the business development manager for SeaErra. I always like throwing in the personal side too. I see she's a women's national champion, tennis player for Israel as well. So that's awesome. And she's coming across from Israel today. So the comms have been intermittent, but hopefully we'll have her up soon.
Yeah. So hi everyone. My name is Yael, and I'm the business development manager of SeaErra. I assume that most of you haven't heard of SeaErra. Please pass the slide. Since we are a new startup that was spinned out of the Marine Imaging Lab at Haifa University, which is led by Dr. Trevitz, although we're still a small upcoming startup, we believe our technology and innovative AI-based solutions open up a new era for the blue economy. Please pass. You see, all the capabilities computer vision opened up for us in land and in the air are not really available underwater because of bad visibility, exactly as you see on the left of the screen. You see, this is the challenge and pain point that we are trying to solve. On the right, you see the output of our core technology, algorithms that increase the underwater visibility in real time, allowing us to see better and further away, close and far away objects. See, the main difficulty is that underwater image deterioration increases with the object distance, and optical water properties change with time and location. This is why common image processing algorithm or filters don't work on such images. We estimate all these properties from the images without any prior knowledge or external hardware, and we reconstruct the scene based on a physics-based model. So we do this in real time and can work at any depth, extending the visibility range by a factor between 2 and 4. So in short, our technology enables the possibility to see better underwater by human eyes for any camera used and in any sea condition. It's very powerful compared to other technologies, and it's extremely beneficial for existing technology and service providers since we improve current operations and we enable all kinds of automatic decisions and analysis for any camera that goes underwater in the ocean and in inland pools. These details that you see on the right and that you can see on the left are details that are very important in any type of underwater operation. Please pass. So our technology is unique in its flexibility and in its compatibility. You see, we work in any depth since our algorithms work in ambient illumination, like you saw before, and also in this video, you can see that we work in artificial illumination. This is a video that was taken from an ROV in the depth of about 100 meters. Please pass. We also have specific algorithms that focus on color reconstruction, and their results are very impressive, and they will be incorporated also in our next versions. Please pass. So, please pass. So what are we offering? We offer a software product that's a plug-and-play standalone software that's already used by paying customers in the market. It can receive input from any camera and enhance it in real time. Our prototype camera is an off-the-shelf component camera with our algorithm embedded in it. See, this camera will provide enhanced output, and from our point of view, will be the first commercial camera with embedded algorithms that enhance the visibility range by a minimum of double. Third configuration is an SDK. It's an offer to strategic partners, and it's relevant for implementation in underwater vehicles and robotics. Please pass. So just here, I just wanted to show a small example of an application for identifying fish. So this is an image before enhancement. Please pass. And this is how it looks like after the enhancement. So you see there's a huge difference in the performance of enhancement of images. Please pass. Another really nice example is this image. Let's see if any one of you can spot a fish here or think it can spot a fish. I don't have a lot of time for the presentation, so please pass. But the enhanced image looks like this. There was one big shark, and this really shows how important it is to work with clear scenes. Please pass. Pass. What you see here is also the capability of doing this under red light. And this allows underwater inhabitants to actually continue their behavior and move freely, undistributed by this illumination, which opens up also the possibility for us to do these observations in different conditions. Please pass. So, pass again. So the market of the underwater imaging is huge. We all know that. And for us, it's the fastest growing sector on Earth. The way we look at it, there's a wide range of industries operating in this market. And our addressable market are all those applications that really gain benefit from seeing better underwater. So just to really finalize, we give the human eye glasses to see clear and further away under the water. While we improve the vision today, we also enable computer vision and AI underwater to perform steadily and lead the market to automation and enhanced performance. Please pass. So really what we want to see is we all just want to see much better. Thanks a lot for this opportunity.
Thank you very much, Yael. I would like to now introduce Leonard Poole, Managing Director for SIDUS Solutions and a fellow surfer. So go ahead, Leonard. We're having audio problems. Yeah. Actually, can we, while that is being resolved, in the interest of time, let's hop over to Dirk Rosen, founder of MARE, and with Tethered Systems. Dirk, are you available, please?
Yes.
Sorry about that. We'll get back to you, Leonard.
Okay, thank you. It looks like in air observations are more difficult than underwater observations. First, having done a presentation yesterday, I wanted to thank Blue Tech and Finest City Entertainment for doing a virtual conference like this. This is phenomenal. I'd love the starting slide right here because it shows a small little ROV in a big ocean, and that's the task we have ahead of us. In our organization, we do thousands of kilometers of seafloor visual surveys, and that's what I wanted to talk about today. So next slide, please. So we can only manage what we know, and in order to do that, we really need to create a baseline of conditions of our world's oceans, track that over time for change, assess if that change is coming from threats or protections, assess the efficacy of our protections, and course correct. And this can be through changing laws, enforcement, or technologies. Next slide, please. So how do we create a baseline? In my opinion, the first thing that needs to be done is mapping. We've embarked upon that on Seabed 2030, continuing the monitoring efforts we have for water temperature, quality, ocean currents and storms, and then identify sentinel sites that are going to be changing for further study. And this is where I feel the visual surveys need to be performed to create inventory of resources and that visual baseline for how things are changing over time. Next slide, please. So in our world, the things we're inventorying primarily are fish and invertebrates and the habitat, as well as sea fans, deep sea corals, and sponges. And then if you get into deeper waters, you have all the minerals that are being sought after for battery technologies and other uses of strategic minerals. Next slide, please. And the reason we need to do this worldwide is we have about 133 countries that are touching our world's ocean, and we need to train and equip those nations to manage their own ocean. And then we have portions of the ocean that are the EEZ of no one, and those are going to be exploited as well, and there needs to be eyes on the seafloor to see how those areas are tracking over time. Next slide, please. In our world, this is where we work. I call it the biomass zone. We work down to about 600 meters, 650 meters, 3,000 feet. We actually have Leonard Poole's cameras from SIDUS, as well as his camera tilts on our system. We also, for the shallower work, we have a Blue Robotics ROV that we have put under continuous electrical control from the surface. So with our fleet, we are assessing all the different zones down to those depths. Next slide, please. And this is how we perform our work. Our ROVs, our remotely operated vehicles, are small. We deploy from what we call ships of opportunity of all different sizes. We fly the vehicle away from the ship using the umbilical to get real-time control and high-definition video back, and then we assess the seafloor down below. Next slide, please. And this is how we do it. We call it a strip transit methodology with pre-programmed paths along the seafloor. We inventory everything, habitat, fish, invertebrates. We pass it over to our team of marine biologists. To date, we have thousands of kilometers of seafloor surveyed, millions of critters identified down to species level, which creates a data set for machine learning, which we are embarking upon. Next slide, please. So this is an example of success. These are marine reserves off of Santa Barbara, California, the changes between 2009 and 2014. This next slide on the blow up, you can see a huge increase in fish populations. Turns out it was 280% increase. It was actually over a 10-year time period, but it was inside and outside those fished areas or reserve areas. And that means that the fishermen are doing better, everyone is doing better. Next slide, please. There's also demise. We were able to witness a decline in sea fans in those same general areas. We didn't notice it in 2005 or 2009, but when we had a huge warm water event off California, it decimated some of the shallower sea fan populations. We were able to go back through our archival and baseline information to document the change over time and trace it back to these warm water events. Next slide, please. When we go and talk about deep sea minerals, as Sam was alluding to earlier, we have to be really careful. Some of the collateral damage will be these deep sea coral sponges and vents. Some of the enzymes that are found in these animals and deposits are currently being used in COVID-19 testing and vaccine trials. They're also in the pharmaceutical chain of drugs that are being used right now. And the reason is these animals can live for 10,000 years. They're rooted to the seafloor and they can't move, but they have to heal themselves. And those properties are working on humans too. Next slide, please. And they may be more valuable than the marine resources at the end of the day. This is an example of a coral garden. If you see one that's white, that's already dead and been co-opted by another animal. So these are resources we don't want to see extinct. Just last year we found a new species in Northern California. Hopefully you can turn your volume down there. And just by going down and exploring, which Sam said earlier, we're finding huge aggregations of fish populations in unknown areas, sometimes surrounded by, in this case, a deep sea coral I had never seen before, but was known to science, Marasana. And who knows why they're there? And these fish sometimes are resident and sometimes they move, but these are highly sought after ground fish. Next slide, please. So we're at this incredible crossroads. The tragedy of the commons is unseen and it's peaking now, and yet we have the knowledge, technology, and algorithms to affect that change. That will affect the futures of people that are young now and haven't even been born. Machine learning will make a giant leap for us, but there's difficult. Most people want to jump straight to fish identification, which is very difficult. The derived products, however, are not. This is change over time, species range extensions, marine mineral discoveries, new species discoveries, and then areas of hotspots and biodiversity that merit protection, some of these sentinel sites. And then the next slide is just a run out of some deep sea images. So thank you very much.
Thank you very much, Dirk. Okay, Leonard, are you back on?
I hope so.
And Leonard's, we'll hop over to Leonard Poole. He's the Manager Director for SIDUS Solutions, and let's give it a go, Leonard.
Yeah, thank you. I hope you guys can hear me now. My name is Leonard Poole, and I'm the Managing Director for SIDUS. The last year, I've been focused on the underwater video and the technical requirements that are that everybody comes up against in that arena. We have an exposure with our company to a multitude of client applications, and our desire is to see them through to a successful outcome. And it has allowed me to basically become an expert of hazardous area and subsea video. My start, I was really enjoying Sam's talk because it sounds like she's been at it as long as I have. I'm another one of the gray hair people out here that I love this industry and I love what I do. And so from that, I try to get involved in as many different types of applications as I can. Next slide. Sorry, I forgot about the slide thing. If you'll go to the next slide as well. Our products are beyond video systems. We do all types of robotic positioners. We do illumination systems, laser systems. We do get involved in some software applications, but we do use third parties in order to work with those systems. But our breadth is pretty broad as far as the different applications for both a wide variety of subsea as well as hazardous area. Next slide, please. Whether you're a research scientist looking to get a good data, or you're an ROV operator wanting to smoothly navigate the subsea environment, each client has their own requirements. Next slide, please. If I was going to go build a new house, the first person that I would want to talk to would be the designer. The designer is going to help me manage my way to what that final vision is going to be. And that is exactly how we at SIDUS operate. We have a group of people that love what we do, and so we tend to get involved as deeply as we can with the client in order to ensure that the outcome is as they desire. And that's not Brock and me surfing too bad. Next slide. One of the things that has really set us apart to our competition is the fact that we do offer full, what we call EPC, engineering and procurement and construction. So whether we're using just SIDUS-based products, or we're integrating with other third-party products, or even competitors' products, SIDUS has always had the ability to work as a collaborative effort in order to come to an overall solution. And we want to make sure that every key point is covered front to back. Next slide. The other aspect of that is that we have the desire to ensure that the outcome is fully understood, and we're really unique in the sense that we keep as much as possible in-house technology and in-house capability as possible. There are times that we do have to go out of the house, but we're very fortunate that we've been able to maintain a very strong team. Next slide. Any areas such as robotic positioning, image quality, illumination, understanding any kind of target reflections that may come into play. This is only a small part of the issues that we work with every day, day in and day out. Next slide. The other aspect that we bring to the table is because of our knowledge of what's needed for the technical applications. We can cover every technical aspect of that environment. And by that I mean long durations, highly corrosive environments, high pressure situations, and other operational issues that some of the others may not take into account. Next slide. One of the things that we've benefited from through the pandemic is that SIDUS has been able to maintain everyone within our staff. So we do maintain a full in-house engineering technical capability. We've even been able to add on additional staff, which is, we're very blessed. I can't put it any other way. We're blessed to be able to be in this position. Our engineering capability comprises of circuit board design, firmware development, mechanical design, which also includes optical. And we cover all levels of electrical interfaces, Ethernet networks, power distribution, electromagnetic issues. So we do not interfere with other related systems that the customers may have on their particular platforms. Next slide. Next slide, if you would mind. I wanted to just kind of give you a sample today of the varied systems that SIDUS has successfully completed. My intent was to do nothing more than to have you think about your next application and learn what is possible. Where can we help you? Next slide. In today's competitive world, we understand your desire to get a cost-effective solution, what that looks like, and be able to provide you the best performance available for that, that price point that you're hoping to hit. We live by this, we engineer by this, and we always expect good results. I have just a couple of items I wanted to just to show real quick. We've been talking a lot about ultra high definition cameras. This particular product is our newest, there we go, there's the camera, our newest unit. And this high definition 120 degree field of view camera has built-in PoE Ethernet capability together with onboard storage for that video. So clients that are in a very tight situation, their costs have to be managed. We have a solution to be able to attach that. And we've done that in a broader sense on a lot of other similar type cameras, whether that's for a dive application or some of these smaller ROVs that are out there. So we'd love a chance to chat with you about it, about your program and how we might be of a good fit. So with that, I want to thank everybody and I appreciate your patience.
Okay, Sam, you said you had you want to finish?
Yeah, if possible, I got about a minute and a half left. If you could, I don't know if you could forward to the giant oil rig slide. If it's not going to work, that's fine. DeepTrekker.com, you can find out everything you need to know and more. See, Rusty, I'll get my plug in no matter what.
Did you? I'm sorry, I didn't know if you were bringing Sam's slide up. What is the most surprising application of your product? And I would just real quick, maybe like 20 seconds across the board.
I'll take it. I approached by a filmmaker from Nat Geo, and we built a special housing for him that was crush proof because he wanted to film hippos underwater. He didn't want to get stepped on by the hippos.
Leonard?
Probably the biggest one for us is that we had a client that was using one of our robotic positioners to try to high pressure blast items out of the seabed. And we of course found out after the fact what he was doing because we could have had some other suggestions. But they were literally taking one of our robotic positioners, shoving it through the sea floor and operating it underneath the mud level. And that was, when we saw the video of that, we were pretty impressed.
Okay, Dirk?
For us, it's a salvage of oceanographic equipment. We've had different universities contact us to recover equipment down as deep as 600 meters, and it allowed us to do kind of Rube Goldbergian recovery techniques, and that's been a lot of fun and very different than our bio surveys.
Okay, Rusty.
Yeah, one of my favorites is definitely that lion fishing robot that I shared on my last slide. And there's actually probably 3 or 4 companies doing that, hunting lionfish, and that's never something I expected our products to be used for, but it's pretty cool.
Great. Yael?
I guess for us it was the thing with the shrimps that this company really I didn't know that shrimps were so dirty, and that the water that they live in, and that the way that they are so close to each other. So they were looking to see how those shrimps are actually connecting to each other and maybe cannibalizing and eating each other during the time in their cage. So it was very surprising to learn about how important it is to see how they behave in such an environment.
Okay, and
Sorry,
please reach out to these companies with their contact information as we
All right, let's start again. I'm Dr. Phil McGillivary, the Science Liaison for the Coast Guard Pacific Area. And this is the Sensors, Platforms, and Integration panel. So we have a half a dozen speakers today. People are going to be going in alphabetical order. And in case you didn't hear it, there's also been a talk by the Vice Commandant, who used to work here as my boss, specifically talking about automation and opportunities for the future for Coast Guard collaboration with small industry and large industry as well, as we move into a new era of technology development. So I think if we're going in alphabetical order, the first speaker would be Alex Halterman, who is Quartus Engineering, which is an engineering company that does engineering consulting for a lot of large projects and also some small projects. So Alex is going to tell us about what his company does and how they have become a member of the Maritime Alliance. Alex?
Yeah, thank you, Phil. As mentioned, we're an engineering services provider. So unlike a lot of the companies here, we don't have a product that we bring to market. We are here to help you all achieve your needs, whether that's through expanding your bandwidth or bringing capabilities to bear. Next slide, please. So Quartus got started a little over 20 years ago as a finite element mechanical analysis company, and that core competency is still the backbone of our company today. So we're a simulation-driven engineering company, so we leverage that analysis to bring products to market and drive early success for our clients. In the last decade or so, we've really focused on optical systems development. If you have a good understanding of the behavior of materials over harsh environments, such as maritime applications or space applications, it lends itself well to that precision trade space. In the last couple of years, we've been doing more spaceflight hardware as well as more airborne instrumentation for Earth science monitoring and things along those lines. A lot of our work is done out of our San Diego headquarters, which has a 50,000 square foot facility, including a 5,000 square foot clean room complex that we do there. And in the last couple of years, we've gotten some small business innovative research awards from NASA to further our correlation of analysis to accelerate the development of these instruments. Next slide. So we really meet you where you need us, and this can be a cradle to grave instrument development. We can engage really, really early to take your concept of operations and mature that through the requirement development process. Or we can engage in individual silos that you see here with doing just design, or half of our company is just analysis for our clients' hardware. We also do sourcing, procurement. We have a machine shop, so we do some fabrication in-house, generally to accelerate the development lifecycle. And on the back end of things, assembly, integration, and test, we are a numbers-driven house as a bunch of analysts at heart. We understand kind of the quantitative requirements at the outset in order to, at the end of the day, build an instrument that performs the way we need it to, and we know why it does that. And then we can transition to higher volume production or facilitate the transition to a contract manufacturer if that makes more sense, or do system commissioning or ongoing servicing and upgrading. Next slide, please. And the area that we do this is across a lot of markets and across a lot of applications. As Phil said, we've recently gotten into the Maritime Alliance about a year ago through some work that we've been doing on bathymetric remote sensing, which is kind of the topic of this type discussion. But a lot of our work you can see on the left is high-end aerospace analysis. We also do medical device like implantables like stents, and then consumer product development as well. So optimizing handheld devices for getting dropped and things like that. And then on the right side of things, it is again kind of what Phil was touching upon: automation, intelligent systems, machine learning, image processing. We bring all those tools together to hit the middle column there, which is the precision optical system side of things, the airborne, spaceborne instruments. If you can click again. The remote sensing and aircraft, again, is where we've really done a lot of work in the maritime side of things. We've also done underwater autonomous vehicles, airborne UAVs, and if you can click one more time, The areas that we really see growth is in the automation, imaging, spacecraft, and touching upon some of these other areas as well are areas that we can further help. So we'd love to talk to you, see what we can do to help you bring your products to market and bring some of our engineering capabilities to bear to help you out. And my contact information is on the next slide, but that's the overview of Quartus.
Okay, are there any questions for Alex? All right, well, we can move on to Matt Hull. And Matt is with Teledyne, which is a company far too big for me to easily summarize its activities. So we'll just let Matt tell us about what he's up to with Teledyne now.
Okay, thanks, Phil. So my name is Matt Hull. I work for Teledyne RD Instruments, which is a part of Teledyne Marine. As Phil mentioned before, it's a very large organization. We produce a large number of products and services that cover the full spectrum of needs for marine sensing, instrumentation, and integration. Next slide, please. So what I'd like to talk about today is what we're seeing in terms of the industry trends across the needs from customers and users on the sensor front. And that can involve a variety of different aspects of it, including the hardware, software, platform integration, and the usability of the sensors. Next slide, please. So let's start diving into the hardware aspect. So fundamentally, as we shift more and more to more modern interfaces, and by that I mean in the past there was a lot of reliance on like serial interfaces, but going forwards there's more on IoT, whether it's Ethernet, USB, wireless connectivity, all sorts of interfaces that users, customers expect with today's modern instrumentation. The other key thing is, even though in the past there's been a heavy reliance on low power consumption, particularly for instrumentation which may be deployed for long periods of time underwater, as we're also migrating to more and more platforms which are power constrained and there's more of a payload on board, the power consumption of the instrumentation is becoming equally, if not more, important. The other thing is, as I mentioned before, when you're talking about platforms and you've got a payload involved, the size of the instrumentation, and not to mention the cost, because some of these platforms can become very, very expensive. People are becoming a lot more cost sensitive to the products, and how can we make them cheaper, more affordable, and make sure that they're more accessible to a wider breadth of users out there. On the platform integration front, we're looking at how can we get sensors on a variety of different platforms. And by that, I mean they can be software platforms. Good examples are things like Robotic Operating System, or ROS, or different hardware platforms, different board connections. So the variety is becoming quite endless, but there are some standardization going on. And one of the key things with the platform integration is you need to be conscious of how flexible the interfaces can be for the customers. So the key thing there is identifying, and this is through collaboration with the user base, on what sort of interfaces, what sort of data, what sort of requirements they have for how they interact with the system and the sensors, and what sort of data and feedback they need. Next slide, please. So then there's also the software front. So as we move forward, it can become increasingly difficult for certain people to get access due to security and things like that to drivers and software. So the key thing there is to make sure that you're identifying the needs and the potentially security. Maybe it's a military organization, some sort of defense, or it's maybe in an area where access to things like CDs or USB may not be possible. So the key thing there is making sure that the software can be in the hands of the user base as easily as possible. The other one is platform versatility. And fundamentally, that also means are you basically limiting yourself to just Windows or Linux or a particular OS? So how can you make sure that that software is as much kind of platform independent as possible? And then the other one is, how can you make sure that the documentation meets the needs of what the customers really need, to make sure it's clear, to make sure it's understandable, make sure that people feel comfortable using it and that they can get up to speed on their own and feel like they're being looked after in terms of the user experience. And then that leads into the next part, usability. So when people are using applications, when they're using the sensor, can you make sure that it's easy to use? Can people jump into using it, the application with the minimal amount of documentation? I mean, these days people don't want to read documentation. When people get their phones, no one wants to bust out the manual and start understanding all the fine details. So it needs to be quick and easy to use, and at the same time maintain a large swath of different features. So what I'd like to do now is jump into a couple of examples of some developments that we've been working on. So next slide, please. So we've got the Teledyne Marine NavUI, which is the kind of stands for the navigation user interface software. And the idea with this application, so this is a software platform, and it integrates a variety of different Teledyne Marine products into one software platform, so you can do easy integration. So it's a single access point, which is designed so that you really don't need to dive into the documentation whatsoever. And it contains all the tools and features that you need to get started with any one of those instruments that are supported. And the idea is you can look at it, you can understand it, and get started pretty much straight away. Next slide, please. On the hardware front, we just recently released the Wayfinder DVL. Now, this is a kind of a departure from what we've done in the past, but the idea is small, low cost, easy to use, very accessible. All of the interfaces are public. Documentation is completely online. Works on Windows, Linux, wide variety of different platforms, and everything is completely open source. So this is designed for small robotic systems, underwater ROVs, other small platforms where power, price, accessibility is key for the success of deployment. So this product is quite different from some of our other products, which are a lot more complicated, but this one is designed for versatility. That's it. Thank you very much.
Oh, great. Okay, well, we'll take the questions at the end then. I thought that was a very nice example of some of the issues facing small businesses and large businesses in integrating things. So next, let's go to Ben Kinnaman from Greensea. I have colleagues that work at Greensea. They're doing a lot of ROV work, including automated ship hull cleaning and ROVs for industry and government use. So go ahead, Ben. Tell us what you're up to.
Thank you. My name is Ben Kinnaman. I'm the founder and CEO of Greensea. Next slide, please. So a little bit of background on our company. Our company is entering into our 15th year. I founded the company in 2006. The company was founded on a pretty basic principle. The principle was to make the robots and machines we use in the subsea industry more accessible and efficient and productive for our operators. So as a company, we've always focused on the relationship that we have with our robots and our machines. The relationships we have with them as operators and the relationships we have with them as developers. A critical component of that, I feel, is open architecture. So our company has founded our business based on an open architecture principle to integrating and developing and managing technology in the maritime and subsea robotics space. Our subsea architecture, our open architecture system is called OpenSea. Consists of three primary technology silos: navigation and localization, autonomy and vehicle control, and then human-machine interface. So all three of these are very heavy into sensor integration and device integration, and how we integrate, manage, and maintain the sensors and the devices that our operators and developers need to be productive. Open architecture is also vitally important for speeding the path to the field. So minimizing the development path from lab and engineering floor to the hands of our operators. It's really based on capitalizing on the concept that a solution in the field today is an 80% solution in the field today is much better than a 90 or 100% solution in the field next year. Because it's really not until these solutions get in the hands of our operators and developers that we really start the development of the last 10, 20% of these systems. So that's what open architecture does. So as a business, we have three primary business segments within GreenSea. The first is program support. So in program support, we support operators directly at the deck plate level. So and these are three very, very specific application areas. So maritime explosive ordnance disposal, special operations forces, particularly combat swimming, combat diver mobility, and then ship hull robotics. The other two segments of the company are focused on OpenSea as a platform. And through OpenSea as a platform, we extend our open architecture platform called OpenSea to developers and integrators and system integrators around the industry and around the world. And then we transition developing and maturing technologies into stable products, and that's our original equipment manufacturer segment. So to date, next slide, please. So to date, GreenSea has fielded over 1,500 robotic systems in the subsea industry, ranging from manned submersibles to surf zone crawlers and ROVs and AUVs and gliders and swimmer delivery vehicles and literally everything in between. All of these systems are based on open architecture. And I feel that open architecture is without a doubt the most important decision a system integrator can make when designing or fielding or integrating a new sensor or platform or machine in this industry. Open architecture brings three key values that cannot be replaced or undermined. The first is cost. There is no more cost-effective way to field and manage technology than open architecture. The second is technology. With open architecture, you're standing on the shoulders of those that have come before you. You're leveraging prior technology developments. You're not recreating the wheel. You're moving the ball forward at all times. And then lastly is community. So through open architecture, you are truly leveraging a broad community. And in the subsea industry, we require this. We absolutely rely on this community because we are not the consumer electronics industry. We don't, as manufacturers and systems integrators and technology developers, we don't have the luxury of releasing a cell phone and having 1 million instant adopters in the first week, finding 1 million bugs, and then issuing a version 2, or Rev 2, a month or 2 months later, and all sins are forgiven. We don't have that luxury. We measure quantity and volume in orders of ones, maybe tens if we're really lucky. So for us, achieving a stable technology, achieving true forward momentum and technology adoption and capability in the subsea industry, we rely on community. And that community for us is based on the concept of open architecture. That's it for me. Thank you.
All right. Thanks, Ben. That was a quite good overview of what your company does. And say hi to Carl Lander there for me when you see him. All right. So he's a good guy. Chris Contes, which I probably just murdered your name, but you were working with Delmar Oceanic, which is a company from my good friend Rob Pinkel, whom I've known for a number of decades. We won't say how many. So tell us about what your company's up to with wire walkers and other things.
Certainly. Thanks for having us. So as you mentioned, Delmar Oceanographic is a blue tech company. We're based here in San Diego. And as you also said, Rob Pinkel, there's a lot of roots kind of ingrained at Scripps Institution of Oceanography as well. product for Delmar Oceanographic is the Wirewalker, which is a rapid vertical profiling system powered by ocean waves. If you slide, the Wirewalker is 100% mechanical. It requires no batteries. There's no power for propulsion or anything like that. It actually just uses wave energy to drive itself up and down the water column. So as a slight caveat here, it's actually really tough to introduce the full flexibility of the Wirewalker in just 4 minutes. And so in this brief introduction, if it sparks any ideas or thoughts, I definitely encourage you to reach out to us and discuss a specific potential application in more detail. But in the photo shown here, the system utilizes a surface buoy. You can see that at the top of the image. The surface buoy bounces with the waves as they go by. Suspended underneath that is a wire rope, and there's a weight hanging from that wire rope. So that whole system kind of bounces up and down together as one unit, right? It's going to go up and down with each wave that passes. And inside the profiling body is a cam mechanism that clamps onto that wire, and it ratchets its way down towards the bottom. And at some predetermined depth, the cam is then released, and the profiler floats upwards under its own buoyancy. So it's completely decoupled from the sea surface motion, which means all kinds of different types of measurements can be made from this platform, including things like turbulence and fine-scale measurements like that. So near the surface, the cam re-engages, and the profiler just begins another ascent. So it kind of does that over and over again perpetually. Again, I want to point out that the Wirewalker is 100% mechanical. There's no batteries, no outside power required to propel the instrument downward. The Wirewalker just uses wave energy, and so it's a full-on green type of power. It works equally well in a moored configuration or free drifting as well. So if you can go to the next slide. The Wirewalker was designed to be modular. That's one of the key strengths here. And because Delmar Oceanographic is a sensor agnostic company, we're happy to just integrate whatever sensors of preference you may have. So, of course, some sensors are more appropriate for profiling applications than others, but the modular nature of the Wirewalker allows a really easy integration for testing sensors. So if you weren't sure if something was going to work well, it's actually pretty easy to test it out and to try it. We've done that with various stuff, and I'll show some images in the next couple slides. But the key thing here is that we can tailor the payload for whatever your unique need or application is. Shown in this image is a Wirewalker built for a group at the University of Hawaii. They were interested in biophysical interactions, and in this image in the center, you can see that longer black sensor there, which is a transmissometer. And as you go towards the right, you go past a dissolved oxygen sensor. Then there's a fluorometer triplet with backscatter, so we got like chlorophyll and CDOM and turbidity there. You can barely see PAR at the top of that Wirewalker on the far right. And then behind the hand on the far right-hand side, there's also a CTD there. You can go to the next slide. This image here, there's 3 different Wirewalker builds. I just wanted to point out some of the other possible configurations that it can have. The one on the left shows a plankton imager. This is a Scripps plankton camera built by Jules Jaffe in that lab. In the middle is a optical, a whole bunch of optical sensors, some fluorescence. There's a lot of sensors. There's a lot going on in this middle image. The one I want to point out is that turbulent microstructure profiler from Rockland on the left side of the instrument there. And the image on the right is a fairly basic CTD solution. But what I do want to point out from this image is the bottom right-hand corner shows an ADCP. This is on an adjustable mount. So we were trying out a few different things. But recently we've seen that the ADCP pointing downward and using a processing like a LADCP would, we get fantastic resolution in the vertical as well as with good shear measurements. Next slide. I can continue talking about the Wirewalker and the platform itself for a long time, but I won't. It's more about the data, and that's what I want to highlight here in the next two slides. So this image, there's three different plots showing an example from a free drifting deployment. This came from about a 2-week deployment, profiling down to 100 meters. And you can see temperature, salinity, chlorophyll here, and you can really see the resolution that we're getting from the rapid profiling of the Wirewalker. And again, by rapid, if you look at the stats in the bottom right-hand corner there, in this case, we were seeing about 7.7 meters per profile. That's the full down and then back up speed. Took about 7 minutes. Typically, we actually see about 10 minutes for 100 meters profile. And next slide. So in this image, this is an example of a moored deployment. This particular one was monitored wave up here in LA. It was only deployed in about 20 meters of water, but it was deployed for almost a month and collected over 18,000 profiles. So 20 meters, the rapid profiling there, we're talking about 2, sometimes 3 minutes to get up and down that water column. So the resolution that you get in time is phenomenal, which allowed this group to really look into plumes and how the effluent kind of interacts with the internal waves and kind of physics that's going on in the area. I should also mention that because the Wirewalker does profile on a jacketed wire rope, it's actually possible to use an inductive modem and like a wireless telemetry system to get this data back in real time in most applications. So something like this where actionable monitoring might be required, it's possible to get that data in real time. Next slide. So just kind of bringing everything back to the TMA Aqua Optimism statement. If Aqua Optimism does include providing forward-thinking solutions to current measurement problems, I would definitely say that Del Mar Oceanographic falls into this aqua optimistic category. And we can do a lot with one platform. And so, as I mentioned at the very beginning, if this sparked any ideas that you might have, feel free to reach out to us and we can talk about if those sensors will work in a vertically profiling application. The next slide. And just wanted to say thank you.
Okay, Chris, that was very good. I know people in Portugal that have used those to study internal waves at the mouths of river that go from near shore to offshore when the tide changes, and they've been very useful. And you mentioned the time duration for collecting those profiles, which I think it's worth mentioning varies a little bit with the sea state, and that's why the time changes a bit. So that was great. So Pierre Trufigo is from L-Wave, and L-Wave is a company that's doing wave analytics software. Right now, I believe, off of Scripps, or about to be now, I can't remember because I'm not down there, we have a CalWave system. And I've been advising CalWave on how to stay out of legal trouble with the Coast Guard for a number of years. And as many of you may know, they're looking at, the state of California is looking at putting wave energy systems in the newly proposed Chumash Marine Protected Area up the coast a little bit. So I'll be very interested to hear what you have to say about your company. Pierre, go ahead.
Yeah. Good morning, good evening, everyone from France. So Airwave Company, so we've been founded in 2018, so in France, and we work on a new detection technology called the electric sense. It's a biomimetics technology, biomimicries, and it is inspired by some tropical fishes who live in very muddy and very cluttered waters. And in this complex environment, the vision and the acoustic are not efficient. And the natural evolution has led this fish to develop a specific perception sense, so the electric sense. And so Airwave varies this mode of perception, and we develop some electromagnetics innovative system. Next slide, please. Thank you. So the electric sensor, we are on active electromagnetic detection system. Very simply, we generate an electromagnetic bubble around the vehicle on which we have integrated our system. And we will measure in real time the disturbances, the modulation of this electromagnetic field by an object which penetrates this electric bubble. And with some specific algorithms, we obtain a real-time 360 degrees electrical image of the environment. And so this electrical image, so it's a real-time and 360 degree perception. So we detect, but not only detecting, we locate and we characterize the object. So we characterize its size, its shape, its material too. We say in real time if the object is a metallic or non-metallic system. And the system is efficient in complex environment, so it is efficient in turbid water, and so it completes the camera when the turbid water is turbid and the camera is blind. It's efficient in very cluttered environment, especially in very close approach to an underwater infrastructure. And then we will complement the sonar, which we have some troubles in close approach or at the interface between the seabed and the water, or the air and the water. And the electromagnetic fields propagates into the sediments. So the system is also efficient for the detection of buried objects, so the pipeline, the cables, the mines, or the UXOs. And so regarding the integration aspect, we have very low burden technology, and the slide after depicts that. Next slide, please. So from a technical point of view, so the system is composed of 3 main blocks. The first one is this pod. It's 40 centimeters long, 5 kilograms in the air. It's a very low energy consumption, less than 30 watt. We performed some tests this week, and we were around 10 watt of total consumption of the system. And so this pod integrates the electronics that generates the electromagnetic field and the embedded algorithms. And then you have some electrodes. These electrodes are installed on different locations of the vehicle, so an ROV or an AUV. And so these electrodes generate and receive the electromagnetic fields. And then we have the software. So the software, when it is used for ROV, the software so depicts to the pilot the electrical image of the environment. And when we are installed on the AUV, we are just simple data transfer to the navigation central of the AUV. Next slide, please. So this slide on the picture on the right, this is the real-time electrical image that we obtain. So this is what for example, a ROV pilot will see on its screen. So we have different views of the environment. So the main one is the 3D, and so all around, so 360 degrees perception. So here we can see the pillars of wind offshore jacket. So in real time, so the refreshment rate is around 30 Hertz. So in real time, you have the position and the evolution of the vehicle faced to this structure. And so on the right side of the panel, you have some projected views, the top one, side one, and back or front one. And so this is the image that we obtain with our sensor. So this is what gives the electrolocation, the electric sense. And so we obtain the same type of visualization for pipelines or cables. So our system is used for ROVs, for IUVs, and so for the detection and the tracking of objects, so including the buried ones. Next slide. Okay, and this is the last one. So just a slight small picture of the current sensor. Thank you.
Okay. Pierre, I'm sure there may be some other people who have questions, but I have a question for you also. One thing that I didn't quite get from your presentation was the spatial coverage of that EM bubble. What would that be roughly?
The range of the system? Yeah.
Yes.
So the detection range is 3 to 5 times the length of the vehicle. So actually, it's the typical factor is the distance between the electrodes, and so for I would say classical system will be 3 to 5 times. For example, AUV of 5 meters long. Detection range is a radius of 25 meters.
Okay. And so have you found that things like tracking buried cables is what have been the main uses for your system so far?
Currently, the one very growing market is the wind offshore one, and so the market is the tracking, detection and tracking of power electric cables. So these cables are buried between 50 centimeters to 2 meters depth of burial, and current systems are quite inefficient for detecting these cables, are very complex to use, and so this is one major market. Second one market, there's the defense market, of course, which detection of UXO and mines is of great interest for us.
Yes, there's no shortage of UXO and mines out there. I've done some work in Croatia, and the Croatians have mines like over 100 years old. They're everywhere. So we're still trying to figure out how to get some of those removed. And they also have a lot of shipwrecks in Croatia. And I think that even though not all, some of the shipwrecks they have date to 100 BC to 100 AD, which probably don't have a whole lot of metal. But there are a number of other shipwrecks, and I can see some of the marine archaeologists finding that system possibly very useful as well. So, okay, well, we have about a minute left. Does anybody have any other questions on some of the aspects of technology? Okay, well, I think as I said, well, why don't you just say it, because I can't see it because I forgot how. What are the interoperability questions in this area of incorporating sensors and platforms was the question. So I know that there is a communications standard committee that's working in Europe to try and get standardized communications. So are there any other comments about that? You all talked a little bit about the robotic operating system. Yeah, go ahead.
Yeah, just coming from the platform that we have is 100% mechanical. So the integration that goes on is a lot of times between various sensors. So if some sensors or loggers can talk to other loggers, it makes our job a whole lot easier than having a central logger on board our platform.
Yeah, well, that's something I think we're going to be dealing with in the future, and I see that we are out of time. So thank you all. I enjoyed all of your presentations.
Thank you.
And
Thank you. Bye-bye.
Thanks to our technical assistant, too.
Good morning. I'm Stanka Willis, the president of the Marine Technology Society. MTS is over 2,000 members in 20 countries and devoted to fostering the diversity of use of marine technologies within the research, government, industry, and military sectors. Welcome to our session, Batteries, Cables, Connectors, and Housings, Oh My. This session is not just about the components, but it's also about a discussion on new business models for these components. Before I introduce our speakers, let me tell you how we'll run the session. Each of our speakers are going to give a short presentation. We'll then ask 1 to 2 questions to begin the discussion, and we'll also answer questions from the audience. Let me introduce our speakers in the order in which they'll speak so we can get right to the session. So Rusty Jehangir is the founder and CEO of Blue Robotics based in Torrance, California, which designs, manufactures, and sells components and systems for marine robotics, including the T200 thruster and the Blue ROV2. Started in 2014 through a Kickstarter campaign, the company now has 250 enabling components, 55 distributors around the world, and thousands of customers. Matt Moldovan is the co-founder of Suburban Marine. He has years of experience in product engineering, design development support. He has a patent for autonomous profiling winch for using on moving boats and for a coaxial propeller-driven system for use on unmanned area vehicles. Matt was the lead engineer of the Oceanographic Observatories Initiative at Scripps Institute of Oceanography. And Sean Newsom is the founder of Shorebreak Technology, providing product representation and business development consulting services for the blue tech community. Based in San Diego, Shorebreak Tech focuses on unmanned systems, sensors, and equipment that minimize risk to personnel, protect critical infrastructure, and contribute to the supporting the health and understanding of our world's waters. He has participated in humanitarian work using maritime robotics in Japan, following earthquakes and tsunamis, consulted for NIST in developing testing standards, and is a member of the San Diego Unified School District's Blue STEM Advisory Panel. So Rusty, let me turn it to you to begin our presentations. Rusty.
Sure, thank you, Zdenka. So hello everybody, thanks for having me. We can jump to the next slide here. And then click again. So my name is Rustom Jehangir. I go by Rusty, the founder and CEO of Blue Robotics. There's my email address if you want to reach out to me. My company is Blue Robotics. We're in Torrance, California, just outside of Los Angeles. We have about 35 employees right now. And I founded the company in 2000 with a mission to provide low-cost, high-quality enabling components to enable the future of marine robotics. The title of this panel discussion is like exactly why we exist and exactly what we do. So I thought that was cool. Go ahead. All right, so I'll tell you a little bit about our start. This was our first product in 2014. It's called the T200 underwater thruster, and we launched this product. I came from a drone background actually, and I realized I was doing a fun project, wanted to send a solar-powered surfboard from Los Angeles to Hawaii, and it's kind of just a crazy idea. In the process, realized that there's no components for marine robotics, particularly the thrusters here. I found one for $700 with an educational discount and one for $3,000. I needed 2 of them. I was trying to build something out of my living room. Realized there was a huge market for this and designed a thruster that was smaller, more efficient, very multi-purpose, well documented, and when we launched it, about 10 times cheaper than anything else on the market, and it's still multiple times cheaper than anything else. Can you go ahead? We launched that product on Kickstarter, which I think is unusual for a marine robotics company, in 2014, raised $103,000 and sold 600 thrusters, started off our company. Next slide, please. So I want to talk a little bit about why I think components and companies supporting components are particularly important to growth and innovation, leading to success of the Sustainable Development Goals. Go ahead. And you can step through that till that whole column fills in. Thank you. So I came from a background in the aerial drone industry here, and I want to make a comparison. So back in 2010, that industry was kind of just getting started. There were companies growing from garages to being many millions of dollar companies, and it was happening very, very quickly. I think, and now you guys know you can go to Best Buy and you can buy a drone for a couple $100 and it works like amazing, better than any military drone did in 2005. So there's a couple of reasons I think that happened. One was that there were many obvious applications and benefits, lots of excitement about drones. That was coupled with affordable core sensors and processing. Some of that came from the cell phone industry, like IMUs were a couple dollars now instead of thousands of dollars. Open source hardware, meaning that the electronics and the autopilots were much less expensive. Open source software, meaning again that stuff was free. And there was an abundance of affordable drone components, which is really important here. That was because there was an RC airplane industry that had already existed for 20, 30 years. They'd moved their manufacturing to China. So day one in the aerial drone industry, you can buy motors, propellers, airframes, just about anything you want and build a drone, which I think led to a drone industry boom, very high accessibility, lots of exciting applications today. Next, you can fill in the whole next column, please. So marine robotics in 2020, by comparison, has a lot of overlap here. So there's a lot of exciting applications, a lot of obvious benefits, a lot of excitement, new companies starting up. There are even more affordable core robotics sensors and processing now. It's much more powerful. There's much more open source hardware and software. It's all over the place, but I think there's still a severe lack of affordable marine robotics components and sensors. Most of our products are 5 to 10 times less expensive than other things on the market. And across the board, you can find places where things are just inaccessible for a lot of people who are interested. And I think that leads to slow growth and limited accessibility. So I'll tell you how we're addressing that. Please go ahead. So we've developed a line of components, not just one piece or one segment, but kind of across the board. We've got about 250 products in our store, ranging from thrusters, grippers, pressure sensors, batteries, temperature sensor, communication electronics, control electronics, cables, tether cables, lights, and a series of watertight, very configurable watertight enclosures. And we put all of that together into our Blue ROV2 vehicle in the center, which basically just uses all of those components and acts as a reference platform for how you can use the components to build a marine robotics vehicle. You can go ahead to the next slide, please. We also make all of those products very accessible. So rather than requesting a quote or asking for something custom, you can go on our website right now. You can click add to cart on a 2-inch watertight enclosure here, and it'll be shipped out to you later today to help enable your projects as quickly as possible. And we've been doing that since the very beginning. Next slide, please. I just want to point out some of the really cool applications that just want to point out some cool applications and what making components accessible and affordable has enabled around the world. So I'm going to start up at the top left there. That's a high school student named Ivan who built a 1,000-meter capable drop camera for less than $1,000 that he could drop down to the bottom of the ocean and basically get deep sea 360 footage using components. Something like that would be totally off the table for a high school student before this. Next to that is a hobbyist who built a survey boat. They put a Lowrance sonar on there, just built this in their garage for a couple $100. I'm going to skip around here a bit, just in the interest of time. Up at the top right is a crazy looking ROV built by a high school mate robot team. We've enabled a lot of them, given them the ability to build much more complicated and advanced vehicles. On the left side in the middle is a picture from Woods Hole Oceanographic Institution where students are using the Blue ROV2 as a platform for autonomous systems development. Down at the bottom left, you can see a commercial autonomous surface vessel platform. Right next to that, you can see a boogie board with a solar panel. The same thrusters are powering both of those, showing the range of things that you can do with an affordable product. And one of my favorites is at the bottom far right. This is a vehicle that's basically one of our Blue ROV2 vehicles, but exploded and reconfigured into a lionfish hunting robot to capture invasive lionfish in the Caribbean. Super cool application enabled by low-cost components, and scaling that up into a marketable product requires low-cost components. Next slide, please. And that's it. So I'll be happy to answer any questions during the panel discussion. Thank you.
Great, thank you. Matt?
Hey, everybody. Hi, my name is Matt Moldovan. I'm the co-founder of Suburban Marine. We were founded about 2.5 years ago with the goal of transforming the underwater industry through connectors. Next slide. So a common theme throughout the industry, I come from oceanographic exploration, was the severe lack of underwater connectors that are rated for full ocean depth. Personally, I've had experiences. I've been doing this for over a decade. It takes me half a day to order cables, get a quote, send a PO, all that sort of stuff. So we are here to change that process. Next slide. So we're specifically talking about rubber molded connectors. The traditional way that these are made is that you call up the vendor, they put it in the queue, and they mold it and they ship it out to you. If you need something quicker, normally you'll have a pigtail in your shop and then you'll mold on a big hot dog splice somewhere in between. It's haphazard, and we've all been there and made do with things on cruises when we didn't have the components we needed. So our innovation is pretty simple. We have removed that rubber molding bottleneck in our production process. So we do the weighting. You don't have to. We stock all our components. You just order it and we ship it out to you next day. Next slide, please. So the way it works is we take that matrix of configurations you probably have in your shop, which is, I don't know, a couple shelves worth of pigtails and bulkheads and different configurations and Ethernet cables. Instead of that, this is the rubber piece is molded by us. So you choose whether you want a male or a female. Then you're going to choose the type of back shell you want, whether it's a bulkhead or for an inline cable. You can choose different materials. You can choose stainless, titanium, PEEK, a right angle bulkhead, a left angle bulkhead. And then you just choose your locking ring that goes with those accompanying connectors and assemble with potting, which is what you all are doing anyways in your shop. So this gives you the ability to make cables on demand or to your specifications with Cat6 cable, Ethernet capabilities. It really opens the door to what my colleagues at Woods Hole said is the Achilles of the industry. Next slide, please. So the 5 key features of what we're doing, like all of the colleagues on this call, reduce lead time. The really cool thing from an engineering perspective on our connector is that because we've given you access to the back of the connector, you can reduce the untwisted cable length, and so it's Ethernet ready. You can just plug and play all the components that you like and get going with your housings. Inside of our female contacts, there's some special magic. So we have increased contact surface area, and which enables higher current than what you're normally used to in a small pin configuration like this. One other nice to have is that with the locking rings, this aids in the mating and unmating of your connector. So as you unscrew the locking ring from the bulkhead, it actually uses that gearing to disengage the connector from the face instead of having to yank on the cable and potentially damage your connection. Industry standard rating to 10,000 PSI. We've done all of our own testing in-house, and we are here to meet your needs. Next slide, please. So we are here to, again, break down the wall that is the underwater connector industry. We want to see what you can make with our connectors. Get in touch. tell your friends, because it is a small industry. I mean, we all know each other, and word of mouth is way more valuable than Google AdWords. So check out our website, get in contact, let me know what you think. Thank you.
Great, thank you, Matt. And Sean, we'll finish up with you.
Right. Well, thank you, Zenka. And let me just say it's a pleasure to be on a panel with Rusty and Matt, both bringing new technologies to this industry, and it's really needed. So let's go to the next slide, please. My name is Sean Newsom. My company is Short Break Tech. As already mentioned, I do want to give a shout out to the other TMA Blue Tech members that I work with, including Deep Trekker, Halo, Maritime Defense Systems, Marine Advanced Robotics, SubSeaSail, and Quartus Engineering. Next slide, please. So I'm here to talk about Dragonfish connectors, and what Dragonfish does is wet pluggable connectors and finished cable assemblies. Next slide. So Dragonfish was founded by a gentleman named Ray Hom. Ray Hom has been in the business for 3 decades as a general manager, engineering manager, and VP for Teledyne Impulse and Impulse. I used to skateboard across a parking lot to pick up whips from Ray to build cables when I was a technician out of the Navy back in the early 90s. So I can vouch for his experience in the industry. Their manufacturing is in Poway, which is an area here in San Diego County. Tours are welcome. I've given several tours. I'm happy to bring people up and have them take a look. Again, wet pluggable connectors and cable assemblies. And I want to focus on cable assemblies as well. This is as Matt had mentioned, it can be very complicated to order and stock and get cable assemblies and order the connectors themselves in a short period of time. And that's one of the things that Dragonfish, one of the pain points that Matt and Rusty have talked about that Dragonfish addresses. And they do that with systems that are intercompatible with all of the other wet pluggable connector companies out there that you're familiar with. We have a number of repeat customers. I'm really proud of our smallest startups and small end users who are given a relief to and making it easy to get make connectors available again. All the way up to some of the largest defense contractors. Next slide. So both Rusty and Matt talked about pain points, and that's kind of a hallmark of Dragonfish. They want to offer less of those pain points, and I'll talk a minute about how we do that. I also want to point out that every photo of every connector and cable you see is a Dragonfish part. I also want to thank Ron Estevez Photography from TMA for helping us with the photography. But so keep in mind you are looking at production parts in the imagery. Next slide, please. So how do we get rid of those pain points? We have some remarkable terms. No minimum order value. That used to be $1, but then we realized we didn't sell anything for $1. You can buy just one line item. And we're doing 6 weeks or better current lead times. In fact, right now we're doing a lot of 1 and 2 week deliveries. And these are specific pain points that make it hard for small OEMs and startups or people, exploring sensors and technology to get the wet pluggable cables and connectors that they need. And we have easy OEM stocking terms. We try and make it very easy to get quantity discounts. In other words, you can have 4 sets of cables that are all the same end connectors, but different cable lengths, and you'll get a quantity discount across all of them, even though they have different cable lengths. Next slide, please. And in order to keep it short, I want to thank you and thank Zenka and the other panelists.
Great. So I really appreciate all of your talks. And let me start off with a question to all of you is, how did you come to this realization that this supply chain business model had to change? And how do you think you'll be able to penetrate the existing market that's out there? And so who wants to start with that one?
I'd be happy to start.
Rustom.
So I guess most of us are just used to the world working differently outside of this. You can go to Amazon, you order something, it shows up in a few days. if you're an engineer, like you go to DigiKey, you go to McMaster, everybody is used to being able to get parts pretty quickly. When I was working in the drone space, like we could get the parts we needed to prototype something very quickly. And so when I came into the marine industry, it was more unusual, much more industrial looking. Everybody has a request for quote button rather than an add to cart button, and I'm a millennial. That's just not how I like to work. I like to be able to click the button, put in my credit card, and get the order here. Don't need to talk to anybody. I think a lot of people expect that. A lot of people would definitely prefer to do that. So there's a lot of power to get people to purchase through your company, even if you just give them that process, even if you don't have anything else that differentiates you. Like if you sell the exact same product as somebody else, but you make it accessible and easy to purchase, you're likely to be successful with that. If you can offer very valuable products on top of that, then I think that just adds to it.
Great. Matt, do you want to join in? And then Sean.
Yeah, so we're all kind of on the same page. And the way that we got here into the connector business, we didn't really want to become a connector company, but after being at the Woods Hole Entrepreneurs Forum and over the past couple of years talking to our colleagues out there, it was in front of our face going up to see Navy diving sonars on the bench that can't ship because there's blank holes where the connectors should be. And those need high bandwidth Ethernet connections. And our colleagues told us, do this. This is the greatest idea I've ever seen in the past couple of years. Do this. So we went out and did it, and we listened to our customers, and we foresee growing not our catalog, but we want to grow in the direction that our customers need. So as different configurations for connectors, and we push the boundaries of what traditionally is an underwater connector, we're excited to see what happens and how high performance we can get and low profile and small and bringing the cost down.
Great. Sean, your thoughts on that?
Yeah, well, I would say if you're, like I said, we're all trying to relieve pain points, and if you're a small OEM and you're a startup and you've got 8 to 20 week lead times to get connectors that are a fraction of the cost of a system that you're providing, it's just not sustainable in that regard. So there has to be some new technologies and new approaches to how we do interconnect in the maritime industries. And it's not just small startups. I mean, I have a good friend of mine at another TMA Blue Tech company who was lamenting that he couldn't ship a $250,000 sensor because he was waiting weeks for a $120 bulkhead connector. And it doesn't work. So I think all of us are doing our best to offer new and different ways of relieving those issues for the customer. And different approaches work for different people.
So several of you have, okay, well, we'll get to that question in just a minute. So several of you have come from either different backgrounds, one from the aerial, or you have partners who come from transportation. Can you just expand just a little bit on what you think that the marine community can learn from those other communities? I know some of you talked about standardization. It's very complex or one of a kind in the marine. So Matt, if you can take that, and then Rusty and Sean, and then we'll get to the question that's on the screen.
Thanks, Anka. So I have background in aerospace as well. And standardization is key, aerospace, automotive. And, similar to what Rusty has done for the marine industry in terms of thrusters, you see thrusters literally everywhere, and it's fantastic. That only happens through commodification by making it available and bringing the cost down. And it's an organic piece where if we commodify our connector and make it available, easy to use, and break down those barriers, it will naturally become standardized. And furthermore, if you build on that automotive and aerospace spec, we've spent the past couple of years torture testing our connectors and getting proper engineering ratings associated with the performance under depth, the dielectric constants, the leakage currents at pressure. So we didn't just pop a mold out and put some rubber in it, and now we're selling connectors. We have been doing our due diligence as system designers and engineers to make sure that our product meets the performance requirements that are demanded, whether it's Ethernet, high power, or under high pressure.
Great. So Rusty, if you wanted to talk about your background and also answer the question on the screen, that'd be great. And then I'll give Sean a chance to answer from his perspective.
Sure. So I'll focus on the question on the screen, which is, how does your sales portal work overseas, and do you get a lot of orders from overseas? Yes, we do. I can tell you that about 70% of our total orders are outside of the US, so a vast majority. There's much more interest for our products outside of the US than the US. We ship everything through DHL Express. Often, if you're in Norway and you order something from us, it might get to your door faster than if you ordered from a company in Norway. So it works very quickly. Our customers seem to be willing to pay for the shipping cost to make that happen. And there's obviously complications on our end, like having to handle the customs paperwork. We've just gotten used to that because that's what our customers need. So we're pretty good at it at this point. And we have very few issues getting products to other countries.
And Rusty, before I turn it over to Sean, from the perspective of, you come from the aerial business, and you talked a bit about on your slide the comparisons, but can you elaborate just a little bit what you think the marine community could learn?
Yeah, I think an important thing is that many companies focus on figuring out a single solution. They'll make a vehicle that does one thing, and there's not a big focus on empowering other people. And I guess we're approaching it from a different perspective, where you could say we're selling shovels for the gold rush, but we're also enabling people to create a company that has a unique ROV application, or to study some ecological thing underwater that they couldn't afford to do with things that were out there before. And by empowering people, I think you open up a lot more possibilities than just creating a solution for one person's problem. And I think that's what's happened in a lot of industries, and we could learn a lot from that here.
And Sean, did you want to weigh in on this?
Well, yeah, sure. I mean, standardization is critical in everything we do, from trying to use the credit card machine at Ralph's to when you buy your groceries to building your unmanned system. I think what Dragonfish does for standardization is you're not investing in a new type of connector, and there's nothing wrong with that because you're ultimately going to standardize on what you select. But we're intercompatible with what pluggable connectors we're using right now. So we're not reinventing the wheel for you in that regard. It's a complex world putting electronics in salt water. So the less components you can have, the better. The less copper wire, the better. So everything you can do to standardize across your platform or product is going to be critical in the industry.
Great. So I'll ask another question. If the host has questions, please go ahead and put them on the screen. So it's interesting. Okay. Well, let me ask this one, and then we'll get to the one that's on the screen. So, Rusty, it's interesting that you said a majority of your business is overseas. Let me focus a minute on the U.S. market, from the ocean market. What do you all see as the challenges in how we can grow the U.S. market for these, experiments in the ocean, sustained observing, commercial applications? So I'll start with Sean this time.
I'm sorry. I think the question below is addressed closer to me. I thought I would answer that first, if that's okay.
That's fine.
Yeah, the interoperability issues are addressed by one, knowing what connector you're using now, and there's small adjustments that are made to the connector itself in order to the Dragonfish manufacturers to ensure that it's specific to what you're currently using. And I'll leave it at that.
So Matt, do you want to talk to interoperability, and then Rusty?
Oh, about the interoperability, as an engineer, I come from the perspective of Legos, right? You know, if it's a knockoff Lego brick, it doesn't really work. And I have a bin, my kids have a bin that's not quite Legos, and then you have the Legos. And those have been, are tried and true since, I think, you know, we're going on 40, 50 years, and the bricks still work together. So mold making, manufacturing, and tolerances are critical, especially, so you take the toy perspective and then put it underwater, it's magnitude, magnified an order of magnitude larger. So our pin configuration on our connectors are not interoperable in terms of plugging connectors. You can replace and put them into your bulkhead or using standard threads. And we give you the flexibility because you can make really whatever back shell you can dream up.
Cool.
So
I can
Rustom,
address.
do you want to weigh in?
Yeah, I can address both those questions. Let me start with interoperability since we're here. So I think generally it's hard to pick something in this market and plug it into something else and get it to work. You usually have to go through some level of effort, engineering level effort. You need a software engineer, electrical engineer, whatever it is, to connect two things together. I think that's a problem. I don't know exactly how to solve that, but I think we will likely need to move in that direction for everybody to be successful in this market. We approach a lot of that by making our products as open source as possible, so that even if we're not the ones addressing the interoperability and making it happen, we give people the tools, give them access to what they need to be able to do that. It's a lot of work, though. As far as growing the U.S. industry relative to the world industry, I think, well, first of all, I don't think the US industry is, I think the world is just a big place, and the U.S. is a small part of it. So saying that 30% of our sales is in the U.S. is still a disproportionately, you know, per person, that's still a disproportionately large amount of sales. And it's not distributed evenly around the rest of the world. There are specific hotspots where people are particularly interested. Like I mentioned Norway earlier, there's tons of aquaculture. They've got 5 million people. Their entire economy depends on the ocean. So they care a lot about it. And there's a lot of people working on how to do that better there. I think we can do that in the US as well. We obviously have a lot of marine economy as well. And I think we're moving in that direction. So I'm not too worried that it will grow. I think we just need to keep up and keep people excited and engaged in that.
Yes, go ahead, Matt.
Yeah, and if I could add to the growing of the ecosystem, Rusty's done a fantastic job of the open source nature of the product, and it's very parallel to what is done in the unmanned aerial vehicles, the automotive industry. And really it comes down to starting with the software layer and standardizing on our communication protocols, just using what's out there. Use CAN bus, use Ethernet. Don't do some weird thing you invented in your lab. And if we stick with that and the hardware layer supports that, we can grow exponentially. But right now, I still see a lot of colleagues operating in a bubble. As new engineers are born, there's a lot more change happening and a big push towards that direction.
Great. So I'll ask the host if we have another question from the audience. Looks like this is applicable to all who would like to start.
I'll take that. You know,
okay.
In a way, we need to work together. There can be more than one sandwich shop on a street. The industry is large enough and growing fast enough that we all need to collaborate, similar to, you know, how the automotive companies buy parts from everyone else. So Rusty's started this wave of component suppliers and hit on it pretty hard, and that's the direction we're going, and that's why we're all here, we're not offering a $10 million UAV that does XYZ. It's components that enable a new ecosystem of underwater exploration.
Sean, go ahead.
Yeah, I would add, I think both comments are appropriate. I think there's a lot of people in the industry that just kind of think things are the way they are, and that's just the way we have to, deal with it. And so I would just say that, the point of these three companies that are here on this panel today is to kind of disrupt the industry and show you that it doesn't have to be that way. So I think really that would be the difference, is if you contacted these gentlemen on myself and explored maybe a different avenue for the way you've approached your interconnect, your cables and housings.
Yeah, I'll just say that's an incredibly hard question. There's definitely not one thing that would make all the difference. I agree with both of the previous things that have been said. I think in the theme of this particular panel, I think thinking about these individual components and making them accessible would make a huge difference to this industry. There are a small number of companies that are thinking about it that way. And if that continues to take off, it will make a big wave overall that will enable and benefit a lot of people.
Great. So the questions coming in from the audience are really good. Do we have another one? Okay. So let me throw a question out. We're getting towards the end of our session here, so it'll be two parts. One is, all of you are startups. So, give us your challenges and let us know what folks like the U.S. government, how can they be helpful to startups, for example, or different sectors? And also, since I'm going to ask each of you to do that, and we're coming down to the end, give us your final comment on this session. So, Matt, I'll start with you. So kind of your experience as a startup, how can you get help? What are your barriers? And your final comment for the session.
For the marine industry, we're an interesting startup. For the rest of the world, we're a normal startup. We've been in stealth mode for a number of years, self-funded, and really bringing a product to market that's fully fleshed out and ready to go. And that's our take on it. We don't really need much except for you all to tell your friends, because it's a very small industry. If we were in San Diego, we'd all be having beers and going down to the beach. But I know that it's a very small group of people that are actually doing the work subsea and pushing the boundaries. So tell your friends.
Great. Okay, Sean, over to you.
Yeah, well, in terms of how the government could be helpful to startups, I would say, think outside the box and give us an opportunity, number one. A lot of government acquisition, of course, is subcontractors providing platforms and systems of systems, et cetera. So, encouraging them to also explore new technologies would be helpful for our industry.
Great. Okay, Rusty.
Cool. So I guess we don't have very many government customers, so I can't speak too directly to that. I kind of go back to my past point and say that I wish to focus even on supporting the development of individual components of these systems, like connectors. Connectors are a big problem. They're a big enabling product, but if you look at requirements for contracts that are coming out, it's for a very system, like solution level thing, and the component people are just out on their own, hoping that those companies are successful so that their components can be successful. That does work, but if chicken and egg problem, and if we focus more on making really good eggs, there's going to be a lot more successful chickens.
Okay, so we're down to a minute, and so here's the final question for the three of you. So what's the next component, the next area you're going to focus on? So I'll start in reverse order. Rusty, what's your next focus?
Yeah, so we're still a startup, but we're 6 years old. We're kind of in the phase where we're growing from a small company to a medium company and learning how to be more consistent and process-oriented, grow up. We're kind of an ugly teenager, got some problems. A lot of it we're trying to be an adult. So a lot of our focus is on growing our company and building a really strong foundation. We've got a lot of people around the world counting on our products now, and we want them to be able to continue counting on them for a long time. So we are making sure that's the case before we drive forward with a whole lot of new product development. But you will definitely see some cool stuff in the future.
Okay. Sean?
I would just say, hey, our next component is the next one that you're having a hard time getting. All right, we're going to make it. In some cases, there might be some NRE, but we're going to get it done in a short period of time and make it fun to get connectors again. Not necessarily fun, but not a pain. So we're looking for people to help us grow our portfolio by requesting what they need right now.
Okay, and Matt, quick.
Oh, they're not going to cut us off?
No, they are.
Oh, we're cut. Yeah, in the same vein, our customers drive. We're here to meet the needs of our customers. We're not here to shove a catalog of components down your throat. It's literally whatever you need, we can make. We're a lean startup, and we can make it happen.
Okay, great. So I think we're done. Thank you, gentlemen. I really enjoyed moderating and chatting with you today. Take care. Bye-bye.
Good afternoon, everybody. Welcome to this afternoon's panel session. We've got, I think, what's going to be an exciting panel session on communications and swarming robotics. We've got a very diverse group here. My name is Donna Kosak, and I work at L3 Harris Technologies, and I'm currently immediate past president of Marine Technology Society. But on our panel, we've got a diverse group from location-wise, all the way from the East Coast, West Coast, Australia, in the UK, as well as their background and expertise. And I think there's a nice medium where they all come together in this robotics and swarming. So I'm going to start off with Jack Hurley. I'll give everybody a brief introduction here, and then we'll turn it over to the panelists to discuss their technologies. So Jack's the CEO of SurfBee. He's the founder of Lagoon.ai and SurfBee Marine Robotics, and he's the go-to for all things hard in the marine hardware, any kind of hardware. He has military-grade experience in deploying autonomous vehicles on land, sea, and air, and he's the founder of multiple startups, including Firetail Robotics, Brighttail AI, Aeromatic Unmanned, Remote GIS, Timberline, Helicopters, 36T, and Platform to enable humanitarian projects to leverage blockchain. Jack is also qualified as a commercial helicopter pilot, a fixed-wing pilot, and has been involved in aerial agriculture and aerial surveys since the early 90s. So Jack, I'll turn it over to you.
Yeah, thanks very much for the introduction. Yeah, definitely a fair, bit to swallow in that. But yeah, look, I think we'll just start off with a quick video on SurfBee. I've put together just 2.5 minutes, and then I know that I've got another couple of minutes just to give a high level on what we're doing down there. So this video, I'll let it roll. It's from the Great Barrier Reef on a survey we did a few months ago. So I'll let that roll. G'day, so we're out here at the Great Barrier Reef, and we're just trying out a lot of some of the new camera software, and we're out there data collecting at the moment. Just a high level, we've got the boat operating behind us. For waypoint 9. It's on a mission that should take about 25 minutes, and we're doing that on one of the smaller batteries. So it's out here, I don't know if you can see it, but it's mapping at a 5-meter swath. We've got our own proprietary camera sitting in a module we made that's a GPS camera, meaning that we're able to put latitude and longitude on the XF data. So what that means is that every image is timestamped for both video and individual images. We then upload that to our own software that we can then scroll through the images and see exactly what we saw underneath. But it's operating quite nicely out there, doing what it's supposed to do. It's very light, 30 centimetre swell, but it is blowing about 20 knots out there, but it's blowing over the top of us. So it's an interesting little test we're doing. Anyway, thanks a lot. Cheers, bye. So as you saw there, that's SurfB.io, most of it, and there's a little bit of Lagoon.ai in there. So with SurfB, look, we developed three main vessels. One is we build a larval bot, which is a coral baby bot for the Great Barrier Reef. That's a large project we have at the moment for the coral swarming that's about to happen, spawning, sorry. And we will be swarming at the spawning. And the next thing, we also do an ADCP boat, which is a Teledyne, Sontec, and row-ready ADCP. That's the one behind us, that side. And the last thing we do is environmental, and that's where the swarming comes in for us as well on the environmental play. So we have an environmental on-surface robot that has a winch on it, and you saw an image of it there pulling up a Sontec Exo sonde. So what we do there is all our boats have, firstly, 4G. We're connected by 4G at the moment, meaning that I can operate this boat where I'm sitting in my kitchen in Australia with kids around me making their lunch. We could be operating this in the San Diego Harbor in real time, seeing everything in real time, planning missions in real time, and more importantly, bringing up environmental data in real time. So what that means is if we have environmental data in real time, then we're able to make decisions on what we see in real time. And with the help of an AI, a quick example on a project is a methane AI use case where we currently have 10 SurfBs with 4G connectivity, and they have methane sniffers. So they can go up some dirty rivers in Australia and seek out sewage and obviously pollution. So if one unit picks up an indication of a high level of methane, then it can automatically tell the other units to come over to where I am and start mapping that area. So that's a really important use case for multiple swarming of units, and then one of them having the intelligence to tell the others to come together and work on a project together. Without any human interference. So that's the swarming side. Now, I just want to quickly touch on Lagoon.ai. Lagoon.ai is quite new. It's an offshoot of SurfB. What we do there is underwater fish detection, sizing, behaviour. So what we currently work with Griffith University in Australia. We are building and built we think it's a bit of a world's first. It's a underwater AI detection rig running NVIDIA. What we do there is we build a model offline and then deploy the model into that unit. And then it's underwater. As it sees fish, it detects them in real time, works out what they are. So it could be a ludric, a salmon, what have you, and also works out some sizing. Then in real time, we have a communications module back up to the surface. And then a guy can be in a rib boat or a biologist or whoever, and then have this information in real time instead of having to pull the unit up and pull an SD card and sit through hours of footage. So we do all that in real time. At the moment, we're working on a project to deploy up to 10 of these units and then have one rib boat on the surface, and then this data just coming in through a radio network on a floating buoy system. So I think that's me. I'll pass it over. Thanks very much for the quick listen. So SurfB and Lagoon.ai.
Okay, very interesting. Thank you, Jack. Next up is Tyler McCready. He's the founder and CEO of Apium Incorporated, a small robotics company in Glendale, California, developing multi-vehicle management software and hardware relevant to the emerging world of autonomous vehicles for sea and air. The business emerged naturally out of varied experiences in engineering and earth science. Apium is pioneering the use of distributed communications algorithms that let large numbers of vehicles spontaneously behave as one robot. So I'll turn it over to you, Tyler, and you can tell us more about it.
All right, thanks, Donna. Well, that was good intro. I think you hit the highlights there. That we are developing our swarm technology as a management tool so that we can get large numbers of small vehicles out in the ocean to do some challenging jobs that you really need to be spread out for. And I think swarming is going to have an ability to really transform how we approach certain big tasks out in the ocean. If you can go to the next slide. All right, thanks. So here are three examples of some of these large tasks where if you have a large number of vehicles, it's sort of, you get to come at it from a really different angle. So the really obvious one is synoptic data, getting information from everywhere all at the same time. That plot at the top there is a bunch of all the black dots are data points collected by a swarm in less than a minute that are tracking an internal wave. It's a feature that changes rapidly over time, but for a swarm, that's no problem. All the swarm vehicles are basically like pixels. The more pixels you can get, the better your image is going to be, and the swarm can keep taking images, and you can develop a movie of an evolving phenomenon. In the middle, asset protection, or anytime you need to patrol an area. Here, the swarm vehicles are like team members, a patrol group that can be surrounding an asset or intimidating an asset, whatever it needs to be. But the more coverage, the more vehicles you have, the better you're able to do that job. And down at the bottom, something like cleaning up oil or ocean plastic. These are cases where you want to be cognizant of the marine life that's also being that's out there, and you don't want to filter that up. Small vehicles that move slowly can be more environmentally delicate, but of course, if they're small and move slowly, you need a lot of them. And so if you can have a large number of vehicles, like just a lot of helping hands getting a big job done. And with the swarm management, we're able to control the distribution of vehicles. You can go to the next slide. So we developed some of our own vehicles, but we've also been packaging our swarming so that it can be put on other vehicles. Here are just some of our swarm dongles. Each one of these has the swarm instinct on board. It plugs into a vehicle's autopilot, makes it a swarm vehicle, so now it's in touch with its neighboring vehicles, and it makes it so that that vehicle autonomously knows how to act as part of the group, and so the swarm will coordinate itself in detail. And an operator can have just a simple graphic interface and only needs to look at the swarm as one big entity and control, like where it is or what its density is or what particular swarm behavior it's involved in. So we're just trying to make it easy, because a swarm is a big, it's complicated and it can be messy, and we need to keep it simple for the operator. And then the last slide. Just a few examples of some of the projects that we've involved with. We developed some of our own swarm vehicles for gathering data. Because they're autonomously swarming, it's easy to just turn them on and keep throwing them in the water. In the upper right, you see about 40 of them cruising around in a group. The lower left, we've been looking at the more dynamic behaviors, using swarming for traffic management, for collision avoidance. And in the lower right is just an example of some of our swarm technology on some WAM-V boats, where we can control multiple vehicles through a satellite connection to a single one. And that's it. Thank you.
Great. Thank you, Tyler. Next up is Dr. Andrew Nuss. He joined DARPA in November 2017 as a program manager in the Technical Technology Office, TTO. His current focus areas include unmanned maritime systems, robotic naval systems, advanced maritime architectures, and their rapid fielding and novel approaches to increase platform survivability. Prior to joining DARPA, Dr. Nuss was a program manager at the Office of the Secretary of Defense Strategic Capabilities Office, where he led the development and transition of unmanned surface vessels and long-range surface-to-surface munitions. So, Andrew, I'll turn it over here and let you take it.
Great. Good afternoon, good morning, depending on where you are in the world. I'm Andrew Nuss, as Donna introduced. I work for the Defense Advanced Research Projects Agency. If you're unfamiliar with that, we are the agency that's responsible for developing leap-ahead technologies across all of the Department of Defense's services, so Army, Marine Corps, Navy, and Air Force, and now the Space Force also. My focus has been on maritime robotics, largely. So I'm going to kind of take a different perspective on comms and swarming with two programs that I have. So next slide is a brief introduction to a program that we just kicked off a few weeks ago called the SeaTrain program. And this is my different take on swarming. So my view on swarming is it's a tool, a mechanism to integrate multiple systems together to get some greater effect. In this case, I'm physically integrating multiple vessels together in order to reduce wave-making resistance for medium-sized unmanned surface vessels. So these are vessels on the order of a 40-meter size, give or take. So by physically coupling these together, we can kind of cheat physics a little bit and reduce the wave-making resistance by tackling the Froude number, if you're familiar with that, and reducing the Froude number. So here it's my take on swarming, in that we're trying to physically integrate things together to achieve a greater benefit for the whole system. In this case, the greater benefit is that of longer operational range because we're reducing resistance. But in order to do so, we have this physical problem that we have to solve of physically coupling boats together and solving the naval architecture and the hydrodynamic problems. But with that comes, since it's an unmanned vessel is our focus area, we do have these unique behaviors that we have to develop for these kinds of vessels to be able to allow them to make the decisions of when to couple together, when to uncouple, and that might be because they need to go conduct a tactical mission, or they might need to uncouple because there's high sea state conditions or some other environmental condition that may risk their survivability. So while it is a physical problem that we're trying to tackle, it does come with this broader autonomy behavior and system control problem, which in some cases may in fact be a little bit more difficult than the physical hydrodynamic problem. And so that's two of the focus areas that we have with this particular program right now. And then the next slide is a slightly different take on the comms portion of today's discussion. In that I have a program that's about a year in execution called Angler, and the focus of this program is to develop and demonstrate a means of autonomous undersea manipulation. So being able to conduct operations on the seabed and maintain systems and repair systems and do activities on the seabed that we typically do with a remotely operated vehicle. And the reason that we are interested in that is we want to break the reliance on a human to intervene and to control a remotely operated vehicle. We want those missions to be able to be conducted autonomously and without a human in the loop. So my different take on the comms discussion today is that we're trying to design the system so that it does not need comms at all. We recognize the importance of comms and making the investments that the broader community is doing in undersea communications, but we want to try to break the dependence on communications, or at least maybe defer the need for communications for another day or another week or another month, depending on the missions that we're executing. And then with that comes the decisions, the hard decisions that when comms does become available, either we've come to the surface and we have SATCOM communication or some other communication, what is the right information that needs to be transmitted at that time? You may have built up gigabytes or terabytes of information, and the system may not know what the priority is of that information. There might be stale information because you collected it 2 weeks ago. There may be more recent information that just might not be important. So prioritizing, making decisions about what information needs to be retained on the system, what we can let go just to preserve storage space on the robot, and then what is that priority to pass that information once you do have communications, or you're in a safe location where communications would be allowed. So slightly different take on communications. DARPA at large has made a lot of investments in comms and swarming for that matter. But these two programs that I introduced today are kind of a different take on the panel discussion today. And then the last slide just carries a couple more bullet points about my Angler program and some of the focus areas. But I think for now we're good today. Thanks.
Okay, what's interesting here, I know, Jack, you're probably saying a lot of that sounded familiar. I know the daisy tuning that you do, the mission modules, and then the data, prioritizing data. So we're going to come back to that in our Q&A. Let's give Terry Sloan a chance first to tell us about his technology. So Terry is the managing director of Planet Ocean Limited, based in Surrey. Planet Ocean represents gold standard manufacturers of oceanographic and meteorological instruments from around the world, as well as designing and manufacturing bespoke instruments and systems for ocean research. The Ocean Limited is actually one more. Terry has been active in the marine and meteorological industry since 1975, when he began his career as an electrical engineer with Marconi Space and Defense Systems, working on submarine launch weapon systems. So we'll tie that in with the DARPA there. In 2003, Terry formed Planet Ocean Limited to concentrate on the marine and environmental science sector. But then in April 2016, Terry established EcoSub Robotics Limited to develop AUV, designed, developed, and collaborated with the Marine Autonomous Robotic Systems Group at the NOC Southampton. So Terry, take it away.
Thanks very much, Donna, for the introduction. Good afternoon or good evening here in the UK. So Planet Ocean, you've heard, and EcoSub Robotics, essentially the same organisation. We are HQ'd in Camberley with R&D, still based at the NOC in Southampton. So I thought I'd use this presentation mainly to set the scene for the following discussion. 2015, we were involved in an Innovate UK funded project along with the NOC and also what was then ASV Global, to develop a micro AUV. And our mission from that point onwards was to democratize the use of AUV technology, really. I mean, that was our end goal. So slide, please. So I guess many of you will have seen these aerial formations of drones, and of course the swarm diver that Tyler will be well aware of, literal zone swarm of unmanned surface vehicles. Might we see the same level of precision and perceived cooperation in the underwater domain, with many AUVs working together in a similar fashion? On my opening slide, you might have seen that we prefer shoals over swarms, just to differentiate, really. And I've noticed also that these big aerial displays are becoming known as flocks. Almost every conference I've been to in the last 7 years or so, there have been discussions about using shoals of AUVs to collaborate in cohort. We don't see it routinely, and my question is, why is that? Slide, please. Well, I guess Swarm Diver Tyler is not really a $10 device, but hopefully you get the point. So these are the primary reasons that we don't see shoals of larger AUVs doing coordinated routine missions. It's the price of the hardware and the lack of access to GPS or GNSS systems, essentially. And as much as we'd like to, we haven't traditionally been able to deploy 10s or 20s of AUVs routinely with the price points you might find of a Gavia or some similar small AUV. There are exceptions, of course. The guys at Ambari are routinely sending out groups or shoals of AUVs, different shapes and sizes, operating together to achieve a goal with a large amount of autonomy built in. So, but they're still very high capital cost shoals and a lot of human interface to make that work. Slide, please. So here you see a shoal of 13, I think, EcoSubs that we've had deployed down in Plymouth last year, and again in Croatia last year as well. And I think we've addressed what we're trying to do here by lowering the price point, but maintaining the performance and capability of the systems. And this whole network could be controlled by a single pilot. And they achieved what they achieved with this communications using the low-cost nano modems, and then some really smart network layering going on behind that to achieve what we are trying to achieve. Slide, please. So I won't dwell on this, but these are the basic outlines of the vehicles that we're offering. The micro, they're 500 meter rated. The milli, 500 meters or 2,500 meters options. The key thing to note there is the FB. That's the front seat, back seat architecture, which allows us to offer our customers or users or collaborators room in the back to put their software or even hardware, and then just pass us instructions to go where they want to go. We sanity check it, kick it back if it doesn't make sense, and ask them to do it again. So that's our approach to open architecture. If you want to find out more about the individual vehicles, then they're obviously all on the website. Excuse me, slide please. So, of course, in terms of getting these things to behave as a shoal, it's all down to communications and positioning, really. So we've been able to engage in a project this time with the NOC again, but this time with Newcastle University, to implement this practical, capable and affordable solution. And only by working together as a team were we able to do that. You know, we had the truck, we had the vehicle. The Newcastle guys had the really smart, low-cost, reasonably high bandwidth modem, and the clever guys at NOC put together the network layer. And it's a very important aspect of what we're trying to do and what we achieved here, because we found without putting some really clever smarts at that part of the system, any vehicle entering or leaving the network would potentially cause corruption. And by sorting all that out, we were able to put new vehicles in, take them out, move the whole network along as a movable long baseline array, essentially. And that gave us, with some assets on the surface and taking in turns on the surface, that gives us that movable LBL, as I said, using a GPS reference. Slide, please. So that's a quick overview of how we get this network working. You can introduce multiple assets into this. They don't all have to be our AUVs. We have a Hermes box, which is the yellow box on the surface, which could be mounted inside an unmanned or an uncrewed surface vehicle. Could be on an oil platform or one of a number of wind turbines, for example, if we're routinely operating the swarm or the shoal in a wind farm, for example. So they could be fixed or mobile reference points, and they can move along with the shoal. So this whole thing can move and does in real time. Next slide, please. So by doing that, we were able to achieve quite a lot of accuracy and improvement in the overall performance. So as we head off to the panel discussion, I'd just like you to consider this. How much more likely would it have been to locate the flight recorder from MH370 with 200 of our AUVs searching for the 30 days of the battery life, rather than just the one? Of course, the AUVs are just trucks, and it's the sensors that do the important things. We've got a growing team of partners delivering sensors that fit with our vision of small, low power, capable, low cost vehicles. These include imaging, listening, as well as the more common scientific payloads of biogeochemistry. They're equally usable by academia, commercial operators, and the defense sectors. Slide, please. So it's important to realize, of course, that the demand for data is getting bigger and bigger and bigger. The need to sample the oceans for all those reasons are getting more and more vital as we need to know more and more about it. And the lack of temporal and spatial data is shameful, really, over the years. We've got this opportunity to change that in an affordable way. So if you want to talk about it offline, then obviously you can find me in the speaker notes. But thank you very much for listening.
Thank you very much, Terry. Okay, I think now we're going to go to Q&A from the audience. We'll be. Okay, we can do that. And then watching through the presentations, there were a lot of connections and similarities here in what you're doing, of course, because everybody uses comms and the swarming, except for when you're underwater. So one thing about the towing and the carrying to get out, I know, Jack, you have something in that area, and Andrew, you have the sea train. What are the advantages other than just carrying, getting to a destination? Are you, I guess one at a time, because I know, Jack, you've got a different method of this, but I wonder what inspired your method to do the towable daisy chain.
Yes, I'll just start. I'll just do a quick one on that. So, look, I mean, we do have. It's really interesting listening to DARPA with their, with the towable. I think that's an awesome strategy around, being able to get through the rough seas and follow each other, and excellent, But our stuff's really, all our gear is designed as a one-man show, right? So we're this boat behind me can sit in a backpack. It can have a winch on it and be deployed within 5 minutes. You throw it out in the water, it goes and does its job, then it comes back. So as far as having different equipment that sits on it, we're mainly manual coupling at the moment to, if we do have a larger payloads, which we do, the biggest surf bee that we do is a 20-footer that holds a ton, right? So we are working on some inter-island ferry type operations. Where we are, breaking not huge seas, but nice lagoon type, under a meter swell type stuff. But I mean, look, for us, it's we're really just getting into that space and starting to put some intelligence behind things. But yeah, I'll hand it over to DARPA.
Terry, and you also raised your hand as well.
Sure, thanks, Donna. Yes, very quickly. I mean, we've launched the EcoSubs from what is now L3 Harris ASVs. We've launched them from the Spotter unmanned aircraft produced by Southampton University. We regularly launch them by hand from jetties. They could be submarine launched or diver delivery system launched for sure. And that's one of the benefits of small. So really, there's no limit to AutoNaut will be carrying them, and we could certainly be delivered by one of your surf boats for sure.
Andrew, did you want to add anything?
Our primary motivation was to increase the efficiency of the overall system. So that was the teaming. It is very much a single domain teaming. It's just unmanned surface vessels working together. I think you could imagine UAVs flying off and UUVs being discharged and stuff. But the kind of the clear problem we're trying to solve, the box we're staying in, is getting medium-sized USVs out farther. From there, there's a lot of other interesting applications that could be opened up.
Okay, and it's sort of like Tyler's one robot trying to all work together cooperatively and make it easier for the pilot. But in some cases, no pilots. But okay, what questions do we have from the audience?
Nope.
Maybe we didn't.
No, we can see that. Yeah, not directly, but some of our partners will be.
I thought somebody said they came in. What sort of challenges do you all see as I don't know, I'd like to just get everybody's input here in this field. I know the comms challenges, when you have small vehicles, you have some environmental challenges. It varies quite a bit. So Tyler, if you want to start.
Well, sure. I mean, they're the obvious ones of keeping things inexpensive enough and the communication. But an interesting challenge that we've found from putting large numbers out is the reliability of the vehicles, where if you have one vehicle that's 99% reliable, that's great. It's going to work for you almost every time you go out. But if you have a swarm of 100 and each one's only 99% reliable, there are going to be failed vehicles every time you go out. And like I was saying, your swarm is one robot. That failed vehicle that's drifting off, that's another robot. And that's the one that now you have to go deal with that. So while in operation, it's nice that individual vehicles can be lost. In practice, having vehicles fail is a real hassle. So there's just a reliability challenge that's it's a big deal.
Look, I agree, and it's not the reliability of the vehicles, is it? It's the environment they operate in. You can easily get tangled in weed or net or those things, and so you're absolutely right. Then your one man with many vehicles becomes a bit of a joke because you've got half looking for the missing vehicle. So you're absolutely right.
Okay, and I guess so. One comment there. I guess that ties into the DARPA mosaic warfare, where you can actually lose vehicles. You don't care about losing them, versus maybe some instances you really don't want to lose a vehicle.
Yeah, do you want me to talk about this one? Because it's really interesting. This is traffic on the oceans and devices proliferating. So in Australia, in the aerial game, we have to have aerial operator certificates. And Australia was quite early on with that to do drones and actually have licensing. Currently, we're going through some legislation in Australia where it's looking like a lot of our USVs would probably come under a registration, meaning that the vehicles themselves, like this one behind me, would have to be registered with a tag on it. So once that happens, I think that we would have some type of ADSB or location, device to warn other traffic and all the rest of it. But it's really interesting. Look, we put lights on this thing, but that weighs 7 kilos and it's rubber. So it's not going to really hurt too much if it hits. But that's what we're finding in Australia anyway. It's really interesting. So legislation's coming hard at us.
Anybody else like to address this question? I actually wasn't able to see it a second ago, but so there's another question. Are there unique data privacy issues in the international seas, and who owns the data?
I can speak for the science community when they're deploying drifting Argo floats, for example. Certainly, some sensors have to be turned off when they enter sovereign seas. Now, I don't know about the sort of things that we would encounter with EcoSub. Depends on which sector are using them, whether it's science, commercial, or defence, I guess.
And I think some of the wave gliders, there were questions there about the EEZ zones. Could they go through I should just say surface vehicles in general? Could they go through the different countries and things and operate? I don't know how that. Obviously, we're doing it. I don't know if any states or countries any countries don't allow that. Anybody else care to comment on this question? So I'd like to put a question out there. What are some of the unique applications? I know we talked about oil and gas. We talked about plastic pollution. We know there's some DoD applications. And what about tying the underwater surface to the undersea assets to the air surface satellites? Would you like to address the multi-domain applications?
Yeah, I might just do a quick one. So I'm really looking forward to Starlink doing something. We're front and center to try and get a marine project going in Australia. with Mr. Musk, which would be awesome. For us, tying in satellite comms. I know these guys do it. All these guys are smart as. They've been doing it for years, but we're pretty new to it, and we're learning a lot pretty quickly. We've probably come from an angle on the fail fast scenario where we've learnt on the fly, but we've attacked it with a pretty different angle with stuff like this, and we're starting to get a few eyeballs. So from the on-surface satellite to the surface vessel to underneath, hence why this exists now, which sits underneath our surf B, can go down 50 meters, turn around, pan, tilt, and it's all AI driven, right? So actionable data in real time is everything. So so I see a full connection, and I don't see our terrestrial networks doing what we need to do in a satellite environment, especially off the Great Barrier Reef. 4G only goes so far, but 5G's less. So anyway, that's just a quick one for me.
All right. Well, thank you very much, guys. Appreciate the panel session today. Went well. Thank you.
All right.
Thanks, guys. Cheers.